right, we are back. Welcome back, everybody. And the next presenter is Carrie Roberts. We're gonna go and have a hands-on workshop that I'm looking forward to it. Getting started with Atomic Red Team. And without any further ado, I pass it back to Carrie.
Hey, and welcome. I hear that this is streaming in multiple locations. I hope that a lot of people are on and can benefit by this introduction to the Atomic Red Team project. We've got some hands-on labs if you want to stay after and do those. I got a short link here for you if you want the slides, if you want to follow along. You can go to rb.gy/mkl158. And if you're in some of those channels, in the Discord channel where this conference is running and you don't mind sharing that link in those channels so the most people get that link as possible for the slides for Atomic Red Team, that would be great. My name is Carrie Roberts. I have a background in PC, mobile, and web app development. In 2010, I was a web app developer, and I didn't know anything about security, even though I had gotten my degree in computer science 4 years earlier. They didn't teach me anything about security. And my company had my web application tested to see if it's secure, and it came back with a bunch of red critical vulnerabilities all over it. It said this site is vulnerable to SQL injection and cross-site scripting everywhere, among some other things. But that's the first time I was introduced to those words, SQL injection and cross-site scripting. I didn't know what it was, but I read the report and realized what it was. And I was just shocked and humiliated that my application could be so easily and completely destroyed by anyone who wanted to do that as a hacker. And luckily it wasn't live yet. So we got those things taken care of before we went live. But it was a real career and life-changing moment because I realized I couldn't be a good web application developer if I didn't know anything about information security. So from that, after my initial discouragement, from that, I decided to embrace the idea of learning about information security. And I took some training from the SANS Institute, and it was very well done. Decided I want to go for a master's in information security from SANS. And so I finished that back in around 2015. I spent 3 years as a pen tester at Black Hills Information Security. I moved in 2017 to Walmart's Red Team, spent a couple of years there. And then the last 2 years I've been on the Blue Team. I wanted to round out my knowledge. I wanted to understand how the other side works, how the defense works, why things that we do on the Red Team work sometimes easily and why things don't, and what makes it hard, what kind of techniques are hard for Blue Team to stop, what kinds are easy, what can be done to circumvent that, but also on the defense side, what can we do to block these offensive tactics. I am one of the maintainers for the Atomic Red Team project, and also have contributed a lot to the code for that project. And I often speak at conferences and have other open source tools you may have heard of, like the domain password audit tool and Slack Extract. Let's get right into it. The Atomic Red Team project is a library of scripted cyber attacks. So you may have heard of the MITRE ATT&CK framework, which defines tactics and techniques seen commonly used by adversaries. But it kind of falls short when it comes to, okay, I want to see if I can detect, or I want to try doing this technique. What do I need to do? You know, what button do I need to push? What command do I need to enter? And that's where the Atomic Red Team project really comes in. It's discrete commands. You can run this attack by running these 3 commands together. And then you can use that to learn about attacks. You can use that to do research, and you can use that to build your detections. This project was started originally by the Red Canary Company out of Colorado that does managed detection and response. But they've open sourced it, and there's over 150 contributors at this time, and perhaps some of you will become contributors after you learn about it. It's free and open source, community developed, so that's really cool. This what I'm covering here today in this 1 hour presentation, plus the 2 hours of lab, is really a subset of a larger class that I teach. It's a 4-day class, 4 hours a day, so 16 hours of class on attack emulation. You can see the schedule there. We cover MITRE ATT&CK and the attack navigator. We cover what we're going to cover today, and then another section on that. We cover Prelude Operator, which utilizes the Atomic Red Team library, another free project that is similar to Caldera. If you're familiar with Caldera, we cover Caldera and take you through the Caldera training so you can get certified as a Caldera operator. We cover the Vector Purple Team reporting tool, which students love to learn about that. That's also free. And then day 4, some smaller miscellaneous topics with some optional stuff for Scythe. And we make the Scythe part optional because it's not free. And some people just aren't interested because they know they won't be using it, but other people are interested to find out if they might like to use it in the future. But today you'll get a sample of that class. So I'm going to lecture for 1 hour and introduce you to Atomic Red Team. We're going to do some running of commands. And then immediately following, there'll be 2 hours of lab time that you can use, and you'll be given an IP address to connect to with remote desktop protocol client. And then if I can figure out what Discord channel everybody's on, I can answer questions there. Again, there's a link to the slides if you want to follow along. Yeah, so at the end, I'll tell you how to get assigned your IP address so you can connect. But those lab machines will shut down 2.5 hours after class is over, just automatically. So they'll just blink off, and then that'll be it. The lab time will be over, and it won't be offered later, except at future presentations like this, which I am doing another one of these exact things through Black Hills Information Security webcast in April. So there are other options. So just to make sure we're all on the same page quickly, I want to talk about the MITRE ATT&CK matrix, which is what we're looking at here. So it's a grid view of the tactics and techniques used by attackers with a lot of extra information about what groups use those tactics and techniques. So across the top, we have various tactics. For example, initial access is one tactic, and under initial access, there's multiple techniques. For example, one way to get an attacker to get initial access to a network is through phishing. So that would be one technique. Going down each column are the techniques. So under the credential access tactic, we have multiple techniques. So an attacker may be able to get access by brute forcing credentials, guessing passwords, sniffing the network. So those are various techniques. Each of these techniques has a technique number assigned. It's a 4-digit number. It starts with T. Sometimes it has a sub number like .001 there. T1003 is the technique, and the sub technique is .001. That's important because everything in Atomic Red Team is tied to the MITRE ATT&CK matrix by this technique number, and we'll see that when we demo. So a quick note on why it's valuable to emulate attacks. So I did talk about this a little bit, that if we use that library of scripted attacks, for one, we learn about attacks and get ideas for attacks that we could do if we're offensive information security professional, or about ways we could defend against. In addition, we could run those scripted cyber attacks in a test environment so that we could look at what telemetry they generate. And we could also validate that in our environment, everything's working. There's a lot of pieces that have to work together in order for the whole detection and response system to be working. And that's something you can validate with these scripted attacks. So maybe if you run certain attacks every week, and every week you make sure that the events get captured on the endpoint, they get forwarded to the central collection agency, the alert logic runs, it really alerts to an analyst, and an analyst really raises an incident to the incident response team. And then you feel confident that any detections you have developed are still working week to week, because there's a lot of things in that chain that can break. And you can also use these scripted attacks to tune your configurations. For example, if you have a product running like sysmon for Windows, you need to configure that to hopefully record the most important events that help you find and respond to attacks, but ignore everything else, because it can record just way too much information for you to realistically hang on to and search through. So it takes some skill to tune those configs to keep the important things, but how do you decide what's important to identify attacks? If you're running these scripted cyber attacks, you've got that information that says, if I want to know that this thing happened, I need to hang on to this piece of information from each of my systems. And you can also use it to compare security products and see which products detect which of the scripted attacks. So a quick example of one scripted cyber attack or one atomic test. In Atomic Red Team, we refer to each scripted cyber attack as an atomic. So you might hear me call it an atomic test or an atomic. So here's an example of an atomic. It's using bits admin to download and then execute. So here we have 4 simple commands. It downloads a file called bits.bat, but then it uses bits admin to actually start up an executable. In this case, it's just Notepad. But imagine that that's some malware that an attacker is trying to start up. And one reason why an attacker might use bits admin to execute their executable is because the parent process when bits admin starts an executable is svchost.exe. So that looks like something more likely to supposed to be happening in an environment. So it may go unnoticed by a blue team if SVC host is starting something up versus just cmd.exe. And so this is an example of an atomic test that probably no security product is configured to alert on or block, because it really is doing exactly what Microsoft designed it to do. But at the same time, it's not something commonly used. So I work in a very large environment, and I know that it just isn't common to see bits admin launching executables. So with this knowledge, we could fine tune our own custom detections to say, hey, if anybody does this sort of thing, even though I know that it isn't necessarily inherently bad, we want to know because it just doesn't happen that much. Or we could put on some allow list those few systems or people that we know do this kind of thing, and then just be alerted to anything else outside of the norm. And that's really where the beauty comes in with the scripted cyber attacks, is especially these things that these atomic or scripted cyber attacks that probably will never alert by default out of any system, but are rare enough that you could probably build your own custom detection and keep an eye on it. Okay, so real quick about Atomic Red Team. One thing I want to make sure everybody keeps distinguished in their mind is Atomic Red Team is really 2 pieces. There's Atomic Red Team, which is the library of scripted attacks. And then there's various execution frameworks. So an execution framework is something that can read that library and run the commands according to what's specified. So we'll see in the scripted attack, it'll say run these commands in command prompt, run these commands in PowerShell with or without admin. Before you run these commands, make sure you get this set and that set to prepare for it. And after you run it, do these commands to clean up and reset so that you can run it again. So there's a lot of things in that scripted library of attacks that it's handy to have an execution framework that just basically follows the recipe in the scripted library according as it's specified. So there's a variety of execution frameworks. So on that first slide, I mentioned Prelude Operator. So Prelude Operator is a free tool that you can use to execute Atomic Red Team tests. And another example is Caldera. Caldera can import the Atomic Red Team tests and execute them. Red Canary also provides I would call it simplified execution framework. It's a PowerShell script that can also execute these tests according to specification. And that's what we'll be using today, and that you'll be using in your labs. So it's valuable because it's straightforward and it works on the system that you have Atomic Red Team installed, or a remote system, but it requires PowerShell. So sometimes you might want to look at other options like Prelude or Caldera to execute tests if for whatever reason PowerShell isn't a good option for you. Okay, so this is where we're going to back out of this presentation. If you're following along in the slides, you'll just see that the slides are kind of an outline for what I want to remember to demo, but we're going to be demoing it. So what I have here that I'm sharing is actually the lab machine. So if you decide to stay afterwards and do the labs, you'll be RDPing to an IP, and on that system, it's going to look like you see here. So you have the Chrome browser, which you're going to want to use because it has all the bookmarks for the class. And then, so I have this open, and in the bookmark bar of Chrome is this labs link, which I have open here. So here's the labs, the 7 labs that you can do either in the lab environment, or you can do them on your own test VM somewhere. But I don't recommend that you download and install Atomic Red Team over a corporate network because it'll set off some flags. So if you're going to play with this outside of this lab environment, do it on your own VM over a network that you have permission or own or whatever that won't get you in trouble. And you definitely want to start out playing with this on a disposable system until you get comfortable with certain tests that you may then run elsewhere. So here within this lab document, there are links to the slides. At the top, there's the 7 labs. I've already installed Atomic Red Team and imported the module for this demonstration just so that I can keep it within an hour, but you have 2 labs here to do that. If you're going to run these labs at another time, go ahead and download all these documents as well. So that, well, or just grab the link so that you have access to those later. Okay. So before we get to there, first, we're going to go to the Atomic Red Team GitHub repository. So Atomic Red Team itself is a project that lives in GitHub. GitHub is a place where it's easy and convenient to collaboratively develop code type projects, which is what this is. So this is why this project is in GitHub, and you see it under the Red Canary Co. You see there's over 153 contributors. You see a lot of stuff here, which can be overwhelming, but by the time we're done, you should feel better about this. The first thing, let me zoom in a little here. The first thing I want to show is this wiki. So I'm definitely biased about this wiki because I wrote it, but I put a lot of stuff in here that I get asked a lot by newcomers to the project to try to help get people started. So here you see it starts out with the philosophy. It talks about executing tests, and it answers frequently asked questions. It's also got a section on contributing. So that's a big section. If you want to contribute back to this project, it'll walk you through how to do that. There's even demo videos. And then the main Atomic Red Team thing over here, it walks you through the whole GitHub repository and the attack navigator, which I'm going to walk you through the repository right now. So that's the wiki. So remember that. Go to the Atomic Red Team project and then the wiki. Okay, so if we go back, we're looking at all this stuff. So there's a lot of stuff in here that really just kind of supports the project that you don't need to concern yourself with. The thing that you want to look at within all these files is this atomics folder, because it contains the library of scripted attacks. So we go into this project, we go into atomics. And now, with the exception of the first folder, everything has a technique, is a folder with a technique number. So we remember seeing T1003.001 with 001 being the sub technique defined by MITRE attack. And so here we have a folder for every MITRE technique that has at least one atomic or scripted cyber attack in it. So you see there's a lot here. In fact, if you go into this indexes folder, you can see how many there are atomic tests by operating system or just altogether. For example, if we could look at how many tests are there for Windows in the Atomic Red Team project. And so here we could look through all the tests for Windows. So the indexes just have indexes in a variety of formats. They have CSV, Markdown, YAML indexes, and of particular interest is this attack navigator layers. They describe the index in a JSON format that can be imported onto the attack navigator. And if you haven't seen that, it's a great way to visualize coverage of like detections or attacks on the MITRE attack matrix itself. So within this lab, I've also got under MITRE attack, the MITRE attack navigator, but I've also got a link that says MITRE attack navigator art atomic red team art coverage. So if we load that, it's actually, it's actually going to show us let's maximize this. It's actually going to show us a red cell for every technique that has at least one atomic or scripted attack written for it. So here we see, just at a glance, we get a feeling for how well the Atomic Red Team library of scripted attacks covers the entire attack space defined by MITRE. And everywhere you see these little gray bars is actually, you can expand that to see the sub-techniques. So actually, under this technique, account manipulation, there's 4 sub-techniques, and there's an atomic test under SSH authorized keys, but not under the other 3. So if you want to go through and see in detail what's covered, then you can do that. So here, 2 out of 3 of this, or actually 4 out of the 5 sub-techniques are covered here. So that's at a glance, you can quickly see to some level, the coverage level of the Atomic Red Team library of scripted attacks. And these layers are automatically updated. So every time you load this URL, it'll be updated. And if I add a test today for additional cloud credentials, and you load this up after I contribute that test, that'll turn red automatically and you'll see that. So this is always up to date. So that's the indexes. So back to this. Let's look into one of these folders. Let's go into T1016. So inside of one of these technique folders, you'll always find at least these 2 files, a YAML file and a Markdown file. These files represent the same information essentially, but the YAML file is very machine readable. That's what the execution frameworks use to read. But let's load this up. It's really not very fun for a human to look at. Like, you can't quickly understand this, even though the information is there and it's very structured. It's just not fun to look at. So when you're just browsing around to learn about these atomics, it's better to look at this Markdown file. This Markdown is automatically generated from the YAML file when new tests are contributed to the project. So it's always up to date. So here's the Markdown version. So we see it's got nice lists and formatting for easy for us to read. So we see that technique T1016 is the technique of system network configuration discovery. And then in the Markdown file, it actually copies in the description from MITRE attack right here. So if you went to their website to learn about what is system network configuration discovery, you would see this paragraph. So it's copied right in, and it's just here for convenience, so you don't have to pop back and forth. And then it lists out the atomic test. So under this technique, there are 7 atomics scripted library attacks. So let's look at the first one. We have a description of it. It says it's for Windows. It says you should run it from the command prompt. And what should you run? You should run this. So in its most basic incantation, you could use the Atomic Red Team library to just read about attacks. So you could come here and you say, oh, here's the kind of commands you might see if somebody runs this attack, and they would run it from PowerShell or command prompt or shell. So these atomic tests cover Linux, Mac, and Windows, and you can look in those indexes to see how well the coverage is, or click on those links for the attack navigator to see the coverage. There's hundreds of tests for all three of those OSs, so it is multi-OS for the test. But so at a minimum, you could read through this and learn and get ideas for whatever kind of projects you have related to information security. But you could also execute these. So here in our environment, one way we could execute this is we could literally copy this, and we could go over to the command prompt like it told us to, and we could paste these things in and run them. And then we may, depending on our use case, we may go look at what telemetry was gathered when those commands were executed and see if there's some sort of event ID we could trigger on to know that this happened, if we wanted to write a detection for that. But again, not everybody's use case is the same. So that's manual execution. So that's cool. You just have to look at whether it's to be run in the command prompt. If it has to be from an elevated command prompt, it'll say run as admin next to it. And then you have these commands here that you could copy and paste in. Here's another test. It's just a one-liner that you run from the command prompt. Here's this third test is intended for Mac OS and Linux. So you run that in shell. So this doesn't apply. These commands wouldn't work on Windows. Let's look down at a more complicated test. So here we have list open egress ports. So what this does is it runs a little script to reach out from an internal network to the internet and find out which ports it can access the external internet from. So it's like, can I get out of this network on port 25? Can I get out of this network on 26, 27, 28? And so all those ports, if an attacker determines are open, they can use any of those ports that they find open outbound to exfiltrate information. So this is something an attacker might do to determine what their options are for getting out of the network. And we notice some different things. There's a lot more information in this test. We've got an input table. So we've got basically input variables that when you execute this, you could use the default values here for these input variables, or you could specify your own. So now these commands are customizable by specifying your own variables. So we might, instead of when we run this test, maybe we don't want to write the list of open ports to the user's desktop. We want to write them somewhere else for whatever reason. Or we don't want to scan the top 128 ports. We have specific ports we want to scan. So we could specify a different file of ports to scan. And so then we look at the attack commands, and it says we should run this with PowerShell. So if we were to copy and paste this like we did for the last command into PowerShell, we'd get errors because this right here is not valid PowerShell. What this is a reference to these variables. So you see port file right here, and you see port file right here. So these scripted attacks are using these variables. So before you run this, you should substitute the default value here. You should substitute this string in right here. And then you should substitute the output file, you should substitute that in here. So now if we wanted to run this manually, it'd be a little of a pain in the neck because we'd have to copy the attack commands out, paste it into Notepad, grab all these default values or our own custom values if we wanted, paste them in, and then run them. So now we're starting to see why an execution framework might be handy, because we could avoid manual copy and pasting and replacing of text because it would do it for us. And we could also script execution, for example, if we wanted to run these same tests every week to validate our detections. And this test also has cleanup commands. So it says after you run the test, you might want to run this cleanup command, which gets rid of that port file from the desktop. That's not too critical to have that port file laying around, but sometimes these atomic tests do other things that need to be reset on the system, like the atomic itself might set a registry key to a less secure value, and then the cleanup would set it back to a more secure value. So the cleanups are especially important in that example. In addition, this test has some dependencies. And in this case, it has one dependency that says, in order to run these commands, you need to have the port file that was specified, which is that top 128.txt, or the port file that you specify. And then it has some commands here that you could run to check to see, do I have the port file? Yes or no. If I don't, then I could use this to get one. Like this downloads that port file from whatever URL is there, which is Red Canary at this point, but you could have your own port file hosted somewhere, and you could use the execution framework to download your prerequisite file here. So definitely we're quickly seeing how an execution framework would come in handy. Let's jump over to the execution framework. So here we're in Red Canary Co. Atomic Red Team. And just as a reminder, this is where we went into the atomics folder, and we see all the techniques that have atomic tests written. Inside of those, we have those files that describe each test, which is a series of a small number of commands that execute one piece of an attack. Now we're going to back up to the Red Canary repository and go over to the one called Invoke Atomic Red Team. So this is the execution framework. It's the PowerShell script that can read those technique files, those YAML and Markdown files, and execute it according to spec so that we don't have to manually copy and paste and replace input arguments. Again, in this repository, there's a very nice wiki. And over on the side, it tells you how to install this execution framework, how to import the module so the command to execute atomic tests is always available to you, how to list atomic tests, on and on and on. All of this stuff, most of this stuff I'm demonstrating here, so I won't read it off to you, but it's all there for your future reference. Let's see. Yeah, so that's basically what you need to know about Invoke Atomic Red Team Wiki. Now we're just going to go demonstrate this project. So I mentioned it's a PowerShell script. So once you install Atomic Red Team, which again, I've already done, but in the labs you can do it, or if you take the lab documents in your own environment. Man, I keep typing the wrong thing. Oh my gosh, it's a bad day. Okay. You'll have to install it first and import the module, but once you do that, you'll be able to use the Invoke Atomic Test function. So Invoke Atomic Test in general, it works like this. You give it a technique number. So we were looking at T1016, and then you can have it do things like execute all of those atomic tests or just a subset of them that fall under T1016. Or for starters, we could ask it to show the brief details. So that just means show us the tests, the atomic tests that are under this technique. And let's go back to the Atomic Red Team repository and have this open on the side. Atomic Red Team atomics. And we're on T1016, so I just want to cross-reference this as we're playing with this. If we go into the T1016 Markdown, we see 7 tests. And we see that lining up pretty good over here. So we have tests 1 through 7. We have system network configuration, list Windows firewall rules, same thing here. But we see that test number 3 is missing, test number 3. If you remember that test number 3 was that test that applied to macOS and Linux. So the execution framework knows that it's running on Windows, and it's only showing us what applies to Windows. So that's why test 3 is not in the list here. Once we know what tests we're interested in doing more with, we can specify a test number, for example, test number 1, and we could say show details without the brief on the end. And that gives us kind of a command line layout of what you see here on the Markdown file. You see the test name, a description, this description, You see that you're supposed to run it on the command prompt like it says here. Here's the commands that you run, which is the same as here. So what we did before is we copied these into the command prompt and ran them, but with the execution framework, we can just say, we can get rid of the show details, and we can just say run that. And so now what it did is in the background, it started up a command prompt. It entered those commands, and then it showed us the output at the end over here in PowerShell, even though those commands didn't execute in PowerShell. So it followed that, which doesn't save us a ton in this example. But let's go look at the more complicated test, which was test number 5. That's the ports, I think. Yeah. So down here, test number 5 that we were looking at, list open egress ports. This is the one that had 3 variables, and you can see the variables listed here in red: output file, port file, a port file URL. So it highlights those for you. And we see the commands. So here we see ports equals get content port file. We see the same thing right here. Whoops. So we see that command here. But in addition to having the command like verbatim, as you see it here, you can also scroll down and you can see the command with the inputs already put in. So here, this port file has already been replaced with the default value for port file, which is our atomics folder technique, or top 128. So that's already filled in. So at this point, we could just copy these commands because the variables are all filled in, and paste it in PowerShell and run them. But it's easy to just ask PowerShell to do that for us. And we could also say, also run the cleanup commands or whatever. So let's move this over here so we can actually watch this run. So if we, let's clear this screen. So if we take off the show details, we're going to be executing test number 5, the open egress ports. We'll see a file appear here on the desktop afterwards. So from this system, everything's open outbound. So no controls going outbound from this lab network. We can see the same information was written out to the openports.txt. And then at the end, we mentioned there's cleanup commands. In this case, what it does is it just deletes this output file that got written to the desktop. So that we can use the execution framework again to run those cleanup commands. So we just tack on a cleanup flag like that. And then that disappears and our system's reset. That was a really simple example of a cleanup, but you can imagine if services were stopped that need restarted, or registry keys were changed, or other crazy changes were made to your startup folders, the cleanup could reset all of that for you. And with this execution framework, you can now script the execution. So if you do want to run multiple tests every day, you can do that with a simple script to do that, and instead of somebody manually copying and pasting. So let's see, what do I want to show now? Let's show a way that we can specify our own input arguments. So if we want to run test 5, but we don't want to use the top 128 ports, we have a different file we want to use, we can add in this flag here called prompt for input args. And this is all on that wiki, that execution framework wiki, to all these examples. So we could say prompt for input args. Now it says, let's maximize this. It says, okay, what do you want to use for your port file? It says, I'm going to use, well, actually for the URL to download it from if you don't have it. So that's fine. We don't want to change that. So we just push enter. And it says, how about for the output file? So maybe we let's change this one because that's easy to demo. Maybe we say we don't want it there, we want it here. And then we'll go ahead and do top ports because I don't want to have to make another one for the demo. So if we, so now we have a file called here. So that's, you know, not an important distinction, but it does show you how you can change the input arguments. There's also a way, instead of being prompted, because I keep bringing up the fact that execution frameworks let you execute tests unattended. You can also specify your input args with this input args. Instead of prompt for input args, it's just input args. And here you pass it a hash table. I'm just using a variable here called hash table. But before you run this command, you would specify in this variable hash table all your input arguments. So you say for port file, use this, for URL, use this. Anything you don't specify specifically, we'll use the default values, but that's how you can script using custom parameters without having to be prompted manually. Okay, so let's take a look at a different test. We're gonna look at T1485. And just for starters, we'll get an idea of what tests are in there. So we'll show details brief. There's only one test. It's overwrite file with sysinternals sdelete. So before we specified a test number, if you don't specify a test number, it runs all the tests under that technique. So in the last example, that would be 6 tests because one of them was Mac OS Linux. But if we would have just said invoke atomic test T1016, it would have ran 6 tests back to back. In this case, it's all the same because there's only one test. We could invoke the tests like this. There is a special technique number that you can enter, which is all, and it would run all the tests, but it will leave your system pretty messed up. So I don't recommend running all unless you're like in this lab environment and you don't care and you just want to see some blow up. The thing, you know, for one thing, it changes so much and there's interdependencies that it basically does mess up your system permanently. But the other reason is you're just blowing up everything that in the end, you can't, it's not really valuable to you because there is so much on the system that changed and so much telemetry that you can't even wrap your mind about what actually just happened and what should I be seeing. It's just like, it literally blows up the whole thing and you're like, okay, now what? But anyways, one useful thing to do with this is if you actually show details brief, it'll list all the tests that apply to your current operating system. So we can let this run for a second and we can quickly see, wow, there's a lot of things that I could choose from. So that's kind of cool. I'm going to stop it. So back to T1485, and these things actually aren't case sensitive, so I'll do that just to show that. But I don't need a specified test number because there's only one. Let's go ahead and try to run that. And it says sdelete is not recognized as a name of a command that, so basically it can't run sdelete because sdelete isn't on the system. Sdelete doesn't come on Windows by default. So if we go back where it's easier to read about this test, if we go back to the atomics folder, and look at this test, we see there's some input arguments where you can specify where your sdelete executable is and what file that you want to delete. So there actually are some prerequisites here, some dependencies that says in order to successfully run this scripted cyber attack, you first need to have the secure delete tool from sysinternals on disk wherever this variable specifies. So if you don't change the default, then it should be in the temp directory sdelete. And then it's got some commands to check that, but the execution framework can use these commands to our advantage. So we can use the execution framework and ask it to check our prerequisites. And now it reports that in red, you don't meet the prereqs for this test. So if you run it, it's going to fail for sure. And the reason why you don't meet it is because the secure delete tool from sysinternals isn't on your system. So now we can, let's clear this again. Now we could say get prereqs. Like, okay, I don't have sdelete, but I want it. So get it for me, please. So we could say get prereqs. Okay, now it says attempting to satisfy this prereq to get sdelete, and got it. So now if we were to check prereqs, it says everything's good. You can run the test. So now we just get rid of that check prereqs flag and run the test. And if you don't specify a file to delete, it creates a temporary one here in the temp directory and deletes it. So it says sdelete just deleted this 1485.txt successfully. Boom, you just use sdelete to delete something. So then if you're interested in seeing what kind of detectable actions can be found after doing that, you can do that at this time. So an adversary, an attacker, will often use secure delete to overwrite their file in a way that forensics can't figure out what they have done. So it's a way of covering their tracks. I think that's what I wanted to demo live. So we'll go back to the slides. And how are we doing on time? 15 minutes left, so we're doing good. Go. Okay, so each time you run an atomic test, not the cleanup or the prereqs or the show details, but actually execute the attack.
Carrie, something happened to your audio. I don't know if you disconnected your microphone.
Uh-oh. Still not hearing me?
No, I cannot hear you.
Testing. Okay, how about now? No. Oh, shoot.
And if you can hear me, it happens right after you went to the slides.
Can you hear me?
There we go. We can hear you now.
Okay. It's probably not going to be as good of audio since but is it workable?
At least I can hear you from my side, yes.
Okay. I might have to speak up too. Okay, that's a bummer. That's weird. Okay, so back. Do you happen to know about? Oh, it's when I went back to the slides, so not too long ago.
Yeah, it's right after you switch to the slides.
Okay. So when you execute an atomic test, a record of that is kept on the system. Only when you execute the actual cyber attack part, so the attack commands, not when you do cleanups or list tests or get prerequisites, nothing's recorded there. But when you actually execute the atomic test, file is written in CSV format to a default location, but you can also specify with the execution framework where you want this written. But it looks like this. It's got the execution time, the technique number, the test name, the host name, and basically the time, the system that it was run. So you can use that to correlate with your detections that says, hey, I ran this attack at this time on this system. Did we have an alert come up for that? And so all of this can, there's a lot of information here. There's over 650 tests just for Windows. Sometimes it can be overwhelming to try and get started, and it isn't super easy, like, to build a whole program around this. Like, you wish that you could say, oh, cool, I'll just run all the tests and then I'll see what got detected. Well, it sounds easy, but actually making that happen, especially in any sort of automated fashion, is still a lot of work. So you've got to get your test system set up. You have to somehow tie them into maybe your production detections. And then you have to correlate this CSV log of what you actually ran to alerts from a lot of different systems and say definitively this alert was definitely catching this atomic test. So as a hint to get started, in the slide here, I have a link to at least a smaller subset of Windows atomic tests that you could start with. And I handpicked those just based on kind of some criteria, like they're less likely to just outright not work because like Windows Defender would block them and not even let them run, or maybe just because they're particularly cool. Maybe they're easier to understand. They take less setup, so they'd be highly valuable if you were to detect them. Like these things like bit-to-admin that aren't going to be blocked out of the box, but really are uncommonly used that you can realistically do detection about. So I do give some suggestions on a smaller list there that you could use to get started with testing. And some quick notes about how you might set up your test environment. So as I mentioned, first you want to start testing in like this lab environment I have, or on your own VM outside of your corporate network or something, somewhere where the system is resettable if you mess it up. And just get comfortable with atomic red team and the execution framework and the various atomics, because ultimately it comes down to be your responsibility to decide if a certain atomic test is safe enough to run in your environment. So as maintainers of atomic red team, we try to review things and make sure nothing malicious gets into the repository, but it is community developed. It is possible that something could be in there that's undesirable to run on your systems. And so you need to get comfortable with what each test does before you run it anywhere that may impact your system. So with that being said, after you get comfortable with atomic red team, you may do something like get a golden image from your organization. Golden image being the type of thing that gets handed to a new employee. So it's got all the same programs, all the same AV configuration on it, firewall rules that your end users get. You could install atomic red team on there and the execution framework and run the tests against yourself. So atomic red team, I mentioned, you can
run it on the local system where you install the Atomic Red Team, or you can run it against a remote system. So this blue arrow here is indicating you install Atomic on this system, Atomic Red Team, and you run the test against that system too. So it's all on one system. And in this scenario, this represents AV. You have your AV installed, but maybe you don't. So I actually recommend, in my opinion, I like the saying that prevention is ideal, but detection is a must. So in my experience as a red teamer and a pen tester, there's always a way to get around the blocking controls that are on an endpoint. So as a defender, I want to always make sure that if this thing is allowed to execute, maybe they just tweak it a little bit. Oftentimes, to get something to get past AV, you just can remove a comment that says power. I just want blank on the credentials. So I want to say power exploit, but Mimikatz. You know, literally remove the word Mimikatz from the comments of the executable now runs or something. Oftentimes, it's something almost that simple. So, anyways, instead of me wanting to spend my time finding all these little ways around AV blocking controls, I'd rather just turn the blocking controls off and say, okay, if this eventually does end up running somehow, would I know as a defender that it ran? So whether you set up your environment like that or not is up to you. It's actually valuable to run it both ways. Let's run it and see what just wouldn't run. But let's also run it and say if something ran that we thought we would block, but it ends up running somehow, would we not? And in this case, we ship off our telemetry to our production central collection of telemetry. So maybe where we build our alerts off of. So this machine, it is a golden image, but it isn't necessarily on the corporate network, but it reports to the same production alerting system. And in that way, you can verify that your production detections are working. Another way you might set it up is you could install Atomic Red Team on one computer that may not even be the domain join, may not even be Windows. And then you could execute Atomic Test with the invoke Atomic Test execution framework against a remote system. And in this case, the only thing that runs on the remote is the 1 or 2 or however many Atomic Tests that you want to run. So when you install Atomic Red Team, it downloads all of those attack commands and a bunch of supporting payloads, so executables and DLLs that AV doesn't like. And it's going to set off all sorts of alerts. Plus, you have to install the execution framework. The execution framework requires the PowerShell YAML module, which isn't on Windows by default. So when you install Atomic Red Team, you actually change that system a fair amount because you're installing all this stuff. So if you want to have a very light touch on your system you're actually testing, you can install it on one machine and then just execute tests through a PowerShell remoting system or a session. So as long as you can enable PowerShell remoting between the two systems, you could do it this way and have a much lighter touch on your endpoint. And this PowerShell remoting is how the Red Canary and Boca Atomic Red Team project does remote testing. But the other tools like Prelude Operator and Caldera, they do remote testing through a command and control channel. So you don't have to have PowerShell remoting enabled as long as you can establish a C2 connection between the remote and where you want to run the test from. So in that scenario, you might have your golden image with or without blocking controls turned on. You're executing tests from this other system that can be completely independent, and you're not worried about the fact that you have a lot of simulated malware on. In any case, you still report to production log systems. Got some notes here for how you might set up your own lab. You can download a free virtual machine from Microsoft. If you want a domain join lab with multiple computers, there's 2 options to automatically deploy that, free options. which is Detection Lab and Splunk. You click that link and it'll take you to those ideas. I mentioned the wiki has a whole section on contributing, so if you're wondering about contributing, please do that. So as a wrap up, we've got this great library of scripted attacks. We can execute that with any number of execution frameworks, including Caldera, Prelude, the PowerShell script itself, Scythe, all import this library of scripted attacks. There's a great Slack workspace with over 25 people actively talking about not just the Atomic Red Team, but attack emulation in general. And it's a helpful, supportive community. It's great to join. There's a link for how to join here. If you want to learn more about that 16-hour class, you can go to the Wild West Hack and Fist training schedule, where you can learn about it and sign up. And just remember, when you, I'm about to tell you how to get your lab IP. But once you RDP to that system, you're going to start up Google Chrome. You're going to click on the labs link. From the labs link, you'll have access to the slides. You'll have access to the 7 lab walkthroughs and some more information about setting up your own lab and joining the Atomic Red Team SciWorks. So let me show you one of those walkthroughs real quick. So for example, here's one of the walkthroughs. So it goes a little bit over what I went in the slides. It tells you about the repository and then tells you how to install it. So these are how the walkthroughs go. There's a lot of explanation. Be forewarned that when you walk through this, you're actually going to get AV alerts going off and errors. And that was on purpose because I want you to see that and then learn what you need to do to get around that. So don't panic if you see that the installation failed. Just keep reading and it'll talk about why it failed and what you have to do to get around it. But I wanted it to be very realistic because you'll experience the same thing. Okay, so now how to access the labs. I have no idea how many people are interested in running the labs. I've got 300 IPs available that I could quickly upload. I can deploy some more. So to get a lab IP assigned, you're going to go to, let me type this word. You're going to go to control panel. .dchme.online. Okay, so let's go there. Okay, so it's a very simple form. You go there and you click Get IP. I haven't uploaded any IPs there yet, but as soon as I end this, I'm going to upload at least 50, and then depending on how fast those go, I've got several more I can upload. If you run this Get IP before the IP addresses are in there, or if everything's used, you'll get this message that all of the IPs have been assigned. Please check back in 5 minutes. So give me about 5 minutes, I'll upload the first set of IPs. But please only ask for one. So as soon as you click Get IP and actually get one, it marks that IP as used and doesn't give it to anybody else. So that if we have somebody go in here and you get IP, get IP, get IP 500 times, there'll be no IPs for anyone else. So do that until you get one, and then hang on to that one that you get and use that for the labs. Again, if you're in some channel somewhere where there's actually live chat going on, or if Omar, you have a place to put that, if you can put the link to the slides and also how to get your IP there.
Absolutely, I already did. Thank you.
That'll be great. Awesome. And then if you want to send me a message to help me get linked up with the channels where people are at, I can be available during these 2 hours to answer questions. I actually didn't take any questions yet. Are there questions, Omar?
There are no questions. I'm actually monitoring both Twitch and YouTube and Discord as well. There are currently not questions that I actually have seen. However, I did see, a couple of people just saying, hey, I'm going to try to actually get the IP address right now. It wasn't working, so you're working on spinning up the VMs.
Yeah, give me just 5 minutes as soon as I close this down, and there'll be IPs there. If they run out, just within about 5 minutes, I'll load some more. I'll keep loading them up as long as people are using it, within reason. So just hang in there.
Perfect.
Do we want to close the stream?
All right. So first of all, thank you so much, Carrie. We really, really appreciate your time today. Thank you for your supporting always the Red Team Village and the security community. And a quick reminder to everybody, please join the conversation via Discord. As we mentioned, the Discord information is on our website. It should be in the link below, whether you're on Twitch or in YouTube. And our next presenter is Magnon Logan. He will be delivering a presentation about Kubernetes security in a few minutes, probably about 25 minutes or so. So stay tuned, and we'll go in a break right now. Thank you. Thanks again, Carrie. All right, we're offline. No worries. I can barely hear you, but I think that you're saying that you have to get the VMs.
Yeah, I got to get the IPs uploaded.
Oh, no worries. Thank you again. You've been amazing.
Appreciate it.
I'll send you so there is a Discord server that NahamSec, actually has. To be honest with you, it's super quiet. Mostly of the chat is actually either through Twitch or YouTube. I'll send you the invites. You have the Red Team Village one, right?
Yeah.
I'll just send it to you directly.
Yeah, just make sure.
Absolutely. All right.
Cool. I've got IPs uploaded and somebody grabbed one already, so.
Hello, everyone. Thank you for joining. My name is Magno Logan, and I'll talk about Kubernetes security, attacking and defending Kubernetes clusters. I'll be available during the talk to answer any questions via the chat. Okay, so let's start. Just a little bit about myself. I work as an information security specialist for Trend Micro in the cloud and container security research team. I'm also part of the CNCF SIG security team, and I don't consider myself a Kubernetes security expert. I'm still learning, but I'm gonna share with you what I've learned from the past year about studying Kubernetes security. This is the agenda for this talk. We'll try to cover all the topics in this 35 minutes talk, but that's why I want to talk about these topics right now, and we'll go right into them. Just before we start, I just want to highlight this awesome Kubernetes security list project that I created on GitHub. There's the link there, and it has a lot of content and tools, videos, and papers, and everything that you can could use to learn about more about Kubernetes security. So feel free to check it out. Okay, so what is Kubernetes, right? Just to give you an overview, if you don't know yet, but Kubernetes is an orchestration, container orchestration solution, right? It's basically an open source system for automating deployment, scaling, and management of containerized applications, right? So basically containers. And it was originally developed by Google and released in 2014. And today it is maintained by the Cloud Native Computing Foundation. Okay, so this shows here on a high level the Kubernetes architecture. And we can see that we have two major components here. We have the control plane on the left side and the worker nodes on the right side. So we have 3 worker nodes on this diagram here. Basically, you have 5 major components on the control plane side on the left side here. So you have the Kube API server, which handles exposing and receiving API calls, right? You have the etcd database, where Kubernetes stores all its internal information. You also have the kube scheduler, who decides where to run the pods. On the top left corner there, you have the kube controller manager, which is responsible for several internal tasks in the cluster, noticing when a pod does not respond and maintaining the correct number of pods, etc. And also on the you have the cloud controller manager there, which interacts with cloud providers, managing resources such as load balancer and disk volumes. Okay. On the right side, on the worker nodes, you have the kubelet, which is responsible for managing the container runtime by executing containers when necessary and collecting execution information, right? You have the kube proxy, which manages network communication, allowing different containers to communicate between each other. Also responsible for external requests. Excuse me. And you also have the container runtime, right? Which is the one that creates and executes the container themselves. By default, it was Docker, but now that's being deprecated since Docker Shim is being deprecated. But you can use either containerd, CRI-O, or Podman to run your container as your container runtime engine. Okay. And just before we start, just a quick note here. On Kubernetes, you don't deploy containers, you deploy pods, right? So pod is the smallest unit that you have in Kubernetes. It's the smallest deployment unit, and it can contain 1 or more containers. So for example, I can have a pod that with 2 containers. One is the main container, and the other one is the sidecar, which collects logs and metrics and other information, right? Okay, that's good. Okay, so moving on. So today we're going to talk about attacking and defending clusters, right? So we need to talk about MITRE ATT&CK framework, which is basically a framework for development of specific threat models and methodologies in many different sectors, right? So it's just basically a globally accessible knowledge base of opposing tactics and techniques based on real world scenarios, right? And it was developed by MITRE. And we're gonna see here firsthand the new MITRE ATT&CK framework that was published last week. For the first draft was published last week, right? But before we go into that, so Microsoft created their own version of their MITRE ATT&CK framework, which is they call it the Kubernetes threat matrix, right? By Microsoft Azure. They released that last year in April. And has a lot of good information there, and some tactics and techniques that we can see, and highlighted here are the ones that we're gonna demonstrate today in our scenario, right? But this is not an official MITRE ATT&CK framework. This was just released by Microsoft, but it was very helpful and used as a baseline to create the original, the official version of the attack for containers and Kubernetes as well, which was released last week, as I said, February 18th by MITRE, and we've collaborated with them and helped them based on the real world scenarios that we've seen in the wild, based on our research and our honeypots and everything. And so it's nice to showcase here that this is being developed. This is the first draft, and it's always it's going to be improved, and it needs feedback from the community. So if you have any data or information about other real world scenarios, feel free to reach out to me or check out the blog post by MITRE and reach out to them directly. So this is the attack scenario that I created based on the Microsoft one, because MITRE wasn't released yet, right? So basically here I'm describing an attack scenario that a malicious user or an attacker would do to compromise a Kubernetes cluster, right? So basically, I won't go into all the details here about this diagram, but basically you have a web application that's running and it's exposed to the internet, and this web application is running inside a pod, which is inside a Kubernetes cluster, and it's exposed to the internet, and it has a vulnerability there. It has a vulnerability of remote command execution vulnerability, right? So an RCE, which when exploited, the attacker is able to get a shell inside the pod in this case, right? And then from there he or she can do in either like lateral movement, just some basic internal recon, privilege escalation, and from there compromise either the whole cluster or even the cloud environment if it's running on a cloud provider as well, right? So one of the most common things that we see when attacking Kubernetes and Docker as well, we have a lot of articles published on this topic, is that the attackers usually try to automate the scanning phase and identifying open or vulnerable clusters or API servers. And basically when they exploit those environments, either via a vulnerable web application or an exposed dashboard or exposed API server, they try to compromise and the cluster and spin up containers to mine cryptocurrencies, right? So either they spin up containers on the cluster, or they try to, if they can have permissions to do so, they try to spin up new instances, bigger instances on your cloud environment to mine cryptocurrencies, usually Monero cryptocurrencies, right? So just a quick note here. So while doing this experiment and testing, basically I used this vulnerable Drupal version of a web application, right? It's a CMS web application, excuse me. And so we exposed that to the internet via a load balancer on the cluster. And this application has well-known RC, which is the 2018 7600 CV that Drupal get onto. And just basically in less than 24 hours, they were able, like the attackers were able to find that URL and compromise it by mining cryptocurrency as well, right? So just while doing the experiment, and we also have seen that happen oftentimes on our honeypots as well. So how do you find that, right? So how do you exploit? How do you identify that a web application is running on a Kubernetes environment, right? So one of the first things that you can do, if it's running on managed services like EKS, GKE, or AKS, right? Basically, if you can find out the URL of the load balancer, that might tell you that's a Kubernetes cluster, and you're gonna see that by the URL on the next slide, right? Another thing here is exposed dashboards. So Kubernetes had a dashboard enabled by default, which before a few versions ago was enabled and didn't have proper authentication. Another issue is with the Kube API server, where if that is exposed and it doesn't have the proper configurations, then you can reach out to the API server, sometimes even without authentication, right? So by exploiting this vulnerability here, the CVE, we get a shell inside the cluster, inside the pod, right? Okay, so right, I'm able to reach the API endpoint externally. Here are some examples. By default, on an unmanaged cluster, Kubernetes uses the port 6443 for the API server, and on managed services, sometimes is the port 443 by default, right? And you can see here that by the URL, you can see that that's using EKS on Amazon AWS on the second URL, right? So that's easy to know that the applications running here are using a Kubernetes cluster, right? So so that's one of the ways to find out about that where the application is running. And after you exploit this vulnerability, you get a shell inside one of the pods. Either via an exposed dashboard or an RCE, right? Just a quick note here. I think Tesla was hacked a few years ago, 2018, because of exposed Kubernetes dashboard, where the attackers found that dashboard URL. And from that dashboard, they had permissions to deploy new pods and compromised the cluster environment. They deployed the pods to mine Bitcoins, cryptocurrencies, right? So usually Monero, and they basically did that, and Tesla got a very expensive bill on their cloud account, right? Okay, so that's one of the things that we can do. Another tool that's interesting to use is KubeHunter. KubeHunter hunts for security weaknesses in Kubernetes cluster. It was developed to increase the awareness and visibility for security issues in Kubernetes environments, right? And it currently detects 37 vulnerabilities on a Kubernetes cluster. I think it's developed in Python, and it's open source, right? You can contribute to the project as well. Okay, so I'm inside the cluster. I got a shell inside a pod there. What can I do, right? So one of other things that you can do, it's an internal, we call internal recon. right? So, okay, I'm inside the pod. How do I know that I'm inside a container? I'm inside a Kubernetes environment if I didn't have the proper URL that would flag that to me, right? So one of the first things that you can check are is the environment variables, right? So by typing that command there, you can see if there are environment variables related to Kubernetes. So that might show the Kubernetes API server, the ports and everything, right? So you can see that from inside the pod. You also have the service account token, which every pod on the cluster has, right? Which they use this token that's inside that that directory there to communicate with the API server, right? So to perform the authentication and communicate to the API server. So you can use that to impersonate the pod and make requests to the API server as well. So kind of authenticated requests. So you might have more permissions and get more information out of the API server, right? Another tool is the AMI container tool, which is called container introspection tool. You can find out what container runtime is being used, as well as features available there. So that's also going to show if you're running inside a Kubernetes cluster or in a Docker environment as well, right? Other things that you can do, right? Basically, usually the name of the host name of the pod or the container are specific, or they have some suffixes at the end that might give away that that's running in a container environment, containerized environment, right? And other things are the number of processes, right, that's running also on the environment. You can check. Usually the container has a few processes, usually one, right? So, and that's not the case for a virtual machine or bare metal environment, right? So, okay, I got I did my internal recon. I found some information there. I identified that I have permissions to exploit this cluster. I have permissions to create a new pod on this cluster, right? That's great, right? So now we go to the privilege escalation phase, right? And one way to do that is by performing like a pod or container escape via a privilege pod, right? So here's a technique posted by Duffy Cooley from VMware on 2019, where we're creating a pod, a privilege pod here, but it has some override or arguments. As you can see there, has a JSON to overload the spec with partial set of values parts from the JSON, right? So just a quick overview here. On the right side, I have the JSON formatted better for visualization. So basically, first here we see the host PID set to true, right? So which breaks the most fundamental isolation of containers, letting us see all the processes as if we're there, as if we were on the host, right? We have the ncenter here command, which is used to switch to different mount namespace, right? And since that's guaranteed to be the host mount namespace, right? And the privilege security context here at the end is necessary to prevent any permission errors when accessing that path here on the mount, right? So this was also used on a workshop from KubeCon 2019. The source is securekubernetes.com. So just make sure you check that out. That's very interesting. Learning about Kubernetes attacks there. Okay, so let's go to the defense part, right? So defending Kubernetes, like how can I protect my cluster from attackers? Isn't Kubernetes secure by default, right? So where do I start? So the first thing here is protecting your API server, right? So make sure that's not exposed to the internet and accessible by attackers, right? So if I get, if I just make a curl request here to my API server, I get this response. Although that gives me a 403, like a forbidden, since I don't have permissions, I didn't pass any authentication tokens, right? This already shows me that this is a Kubernetes cluster that's running there, right? So this is the default one. So if someone can reach out to your cluster like that, that's already an issue, right? So that should be limited through either like a VPN or firewalls or security groups that only allow your developers and your employees from your organization to access that cluster, even make this simple request, right? Okay. So one of the first things that you can do to protect your cluster is also checking the CIS Kubernetes benchmark, right? So the Kubernetes benchmark is a prescriptive guidance for establishing a secure configuration posture on for Kubernetes, right? It has over 120 security checks for your cluster, right? It was created by Rory McCune and Release Rice and many other contributors as well. And there are specific ones for EKS and GKE. So there's a lot of information there. It's currently on version 1.6.0, which was released on July 2020. And it covers the Kubernetes cluster versions from 1.16 to 1.18. Okay, but how I'm gonna do that like manually, right? So if you take a look at the benchmark, it's a lot of pages, a lot of checks that you have to perform, and it's hard, especially if you have multiple clusters, right, on your environment. That's gonna be hard for you to check one by one, right? So there is this open source tool that was released by Aqua Security as well called KubeBench. They basically check whether Kubernetes is deployed security, validating it against the CIS Kubernetes benchmark. It's developed in Go, and it basically checks all the items from the benchmark and gives you a pass, fail, or warning response. So as you can see here, this is just one of the results, and you can see that my cluster is not very well configured with a lot of issues there, or it wasn't able to detect that if it doesn't have the permissions. But you can see that the master node, it checks the API server, etcd, the worker nodes, and other configurations as well. So I recommend you to take a look. Okay. One of the other things that you can do, right, before you deploy your cluster and your container images, right, is do what we call image scanning, right? There are many tools out there to perform that for you. So basically, you check your container image for known vulnerabilities, malware, misconfiguration issues, and other set of like permission issues that may cause problem if your container is compromised. Some of the tools here that you can use are Claire, Smart Check, Sneak, and Trivy, right? And also there's a scan command that you can basically run if you're using Docker. You can run the Docker scan command, which under the hood uses the Sneak database to check for vulnerabilities and on your container image and dependencies there as well. So I recommend you to check that out. Okay, you check the images, you scan them, they look fine. You did the CIS Kubernetes benchmark, everything looks good. But now you've deployed your cluster running, and it's in production, right? So how do you know that your containers are not have not been compromised and are not doing something funny, right? Like having an open SSH running there, or executing some files, or changing the state of the container image after it is deployed, right? So which something that's a technique that's called drift detection, right? So there's this tool called Falco, which was developed by Sysdig in 2016, and now belongs to the Kubernetes, the Container Cloud Native Computing Foundation, right? Which is basically a cloud native runtime security project, right? Or as they call it, the de facto Kubernetes threat detection engine, right? It's an incubation level project. It detects unexpected application behavior and alerts on threats at runtime, right? So basically, it parses Linux kernel syscalls at runtime, and based on some rules engine, easy like a YAML file rules engine that's easy to read and to create. That rules engine detects the unexpected behavior in a cluster and generate alerts based on these threats. And you can integrate that with other tools as well. So I recommend that you check that out. Okay, that's good. And what are the things, right? What are some basic stuff that you can also do on your cluster without needing third-party tools to protect yourself, right? So basically, you have the pods, right? As I said, pods is the smallest deployment unit on the Kubernetes cluster, right? And so just like containers, you have to limit the resources, the CPU and memory, otherwise the pods can start consuming all the resources available on your node and leaving the other pods with performance issues, right? And possibly causing a denial of service on the node. So the way to fix that is either setting the limiting resources, the CPU and memory sources, specifically on the container, on the pod spec, right, on the YAML file, or you can use this resource quota that applies that configuration to all the pods on your cluster. Okay, one other thing is creating and applying a security context, right? So you can, there are some privilege and access control permissions that you can set on a pod. Here are just a few examples that you should enable that on all your containers to avoid any privilege escalation issues, any issues with writing to the root file system or running the container's root, right? Which is also a big issue there. Also, there are some Linux kernel security features that you can enable. Some of them here are SecComp, AppArmor, and SE Linux that also protects your container and your cluster against some attacks, right? Okay, moving on. There is something called admission controller, which is a piece of code that intercepts requests to the Kubernetes API server prior to the persistence of this object on etcd, right? But after the request is authenticated and authorized. One of these admission controllers is called the pod security policy, or PSP for short, right? And it basically has it can control most of the security settings mentioned before on the security context, but now on a cluster level, right? Unfortunately, this PSP will be deprecated on the next version of Kubernetes, the 1.21, and will be removed on version 1.25 probably next year. So what can you do there, right? There are some alternatives that you can use to other CNCF tools are the OPA Gatekeeper and Kyverno that you can use some policy controller for Kubernetes as OPA Gatekeeper, or Kyverno is the policy engine designed for Kubernetes as well, right, that you can use. Other options that are still in discussion by the Kubernetes SIG off team are two new implementations of the pod security policy. One is called the PSP++, or the Container Boundary Policy, and the bare minimum PSP, which is intended to capture more common use cases and provide a baseline security. So I linked those documents there. They are still in discussion. They are not official and they're not implemented yet. But I think it's important for you to be aware, since that might be an option for you to replace PSP in the future. Okay, yeah, okay, let's see. You've secured your cluster, you protected, you've implemented some of these tools already, right? So, but now you're considering like an insider threat, right? So there's some employee that has permissions to your cluster, and they might have too much permissions and compromise or do something that's harmful to your cluster, either intentionally or unintentionally, right? So on Kubernetes, you have RBAC, which is called a role-based access control. It's basically very similar to access control on most web applications, right? By role, you have like, you can have the cluster admin, you can create new roles and permissions for each of those roles, right? Now it's enabled by default on the latest Kubernetes version. You can check that by checking that that setting authorization mode on your Kube API server. And basically what RBAC does, it has 4 different objects: row binding, cluster row, and cluster row binding, right? And those objects basically contain rules that represent a set of permissions within a namespace. So row is restricted to the namespace level, right? And row binding basically binds these permissions from the row to one or more users, right? So a set of users. And the other 2 objects there, cluster row and cluster row binding, are basically the same thing, but they're not tied to a namespace, and it will be applied to the cluster level. So all the namespaces on the cluster, and so they are more permissive, so be careful with that. etcd, as I mentioned before, is the main data storage for your cluster, right? All the cluster objects are saved here. And we've identified that there are 2,600 exposed etcd on Shodan today, right? So recently, this is a recent search. And just be aware of that if your etcd is exposed, it also has an API that you can interact with. And if an attacker has access to the etcd, they basically can do anything on your cluster, right? If they have write access, they can create objects, delete pods, or anything else, right? Because Kubernetes is always checking etcd to maintain that desired state, which reflects what's in etcd should reflect what's in the cluster, right? So 2 quick things here about etcd. Basically, the encryption in transit is done by default. You can check that by running this command here and checking those files, the certification file and the key file, right? But the encryption at rest is not by default, right? So it's not done by default. Everything in etcd is stored by in plain text, including your secrets, right? Which is an object that is usually used by Kubernetes to store sensitive information, right? So to fix that, you have to create an encryption configuration object that you select what should be encrypted on your etcd, and that will be encrypted at rest as well. But that's not done by default, so be aware of that. And for network policy, also by default, all pods can communicate with any other pod in the cluster. So basically, that's a flat network. And if you have a network background, you know that's not a good thing, right? So make sure that you create a proper network policy for your cluster, right? So like ask questions like, does the front end really need to talk to the database pod, right? So what if an attacker can access the pods on the kubesystem namespace, which is the main namespace for the Kubernetes cluster, where the control plane pods are usually running, right? So Cilium, which is a network, a CNI for Kubernetes, right? Network interface. we just released recently a network policy editor, and that's very nice that you can visualize who can access what on your cluster, and they already give you the code, the YAML file for the configuration that you set there for your network policy, right? So that's nice to check it out. The link is there in the slides. And just to finalize here, another thing that's important for Kubernetes Kubernetes security for protecting your cluster, right, is the Kubernetes audit logs. They are not enabled by default, right? So it's highly recommended that you enable them for security and also for troubleshooting, right? You basically need two things for enabling them: a log path and a policy file, right? So specifying where the location of the log and which policy, so what you want to log. So there are some policies you can log just the request or the request and response or just the metadata, right? And you set those up on the Kube API server configuration, right? If you're running on a managed services, basically, for example, in EKS, it's just a click of a button to enable those logs on AWS, and they go to CloudWatch. And to finalize here, the basic stuff of protecting your cluster, right? So don't forget about those. Those are also important. So update your Kubernetes environment version early and often, right? The latest version is 120, and Kubernetes usually updates their version at least 2 to 3 times a year, so almost every quarter. So be aware of that. Don't use cluster admin for daily work. So treat it like a root user on your system, right? If you can, use the managed Kubernetes service like AKS from Azure, EKS from AWS, or GKE from GCP, because they handle the master node for you, so you don't need to worry about the security of the control plane and Kube API server and all that stuff. Just be aware of their default settings. For example, like EKS, which has the Kube API server URL exposed, publicly exposed by default. And check the CIS Kubernetes benchmark document for more security best practices. They're always updating that to cover the latest version of Kubernetes, so I think it's important to take a look. And with that, I conclude my presentation, and I'm gonna be answering questions on the chat. Okay, thank you.
guys, thank you for joining us in this day. My name is Felipe Pires. I am talking from Brazil, and today we're gonna talk about a very interesting topic that I like a lot. This topic is malware analysis, and of course, I chose to talk today about the PDF malicious. And so, yeah, let's begin, and let's start the presentation, right? Let me share my screen here with you. And we're gonna talk about discovery CNC. It's a command, it's a acronym, right? It means command and control in a malicious PDF using a disobfuscation, encode, and other techniques, right? So let me share here my contacts on social medias. If you'd like to follow me or maybe send me questions, I use it a lot on LinkedIn, sharing the papers and articles as well in Twitter. And I have some projects in GitHub, if you'd like to see, that I talk about the security and threat hunting. So if you have some questions or doubts, you can send me a message if you want, of course, right? And let me introduce myself. I am a security research and security developer advocate at Soup Innovation. Soup Innovation, it's a Brazilian company, right? And we have a simple purpose. By the way, I will show you about the website about my company, right? So I think we have this good definition here by one of our founders, right? At Soup Innovation, our main purpose is to create an exponential growth environment. It provides a lot of opportunities to evolve your career, right? And here I would like to share with you, we responsible to create many open source products, right? We have, by the way, 4, Reach, Charts, and Beagle. All those products, it's open to the community because it's open source, of course. And I'm advocate of the ORUSEC, right? ORUSEC is basically performing static code analysis in your code to try search a possibility or any possible vulnerability in your code, right? And binaries and many things that you have in your project, right? Let's return here. I am advocate at Hacking is Not a Crime. It's another very interesting project that I am participating, right? I am sharing here a simple definition about this project. This phrase is a good definition, right? Contrary to the population misconception, behind a hacker is a lifestyle, and mindset. Because usually this expression, a hacker or hacking, many times the media using it the way wrong, right? Like a bad guy. It's not correct to use this. You can use a threat actor or maybe an attacker, but never like a hacker, right? Because as I mentioned, it's a lifestyle, is a mindset. It's not a fashion statement or a move character, right? Hacker is a simple, curious, and outside of the box thinker who creates unorthodox solutions for every problems, right? The actions and the method by each of these problems are solved is called hacking. That is a simple and correct definitions, right? So I am an advocate of this amazing project, and I am a part of the staff team of the DEFCON group São Paulo. It's a very, very good group here, part of the DEFCON groups. I think you know about this DEFCON event, so it's very interesting. We have this kind of group. We have a Discord. If you'd like to, participate with us, we are open to talk with you, because over there, we share acknowledgement, we share the videos, we share demos, we share contents, many things that you can imagine, because it's a community, right? And I am a security research and instructor at Hacker Security. It's a Brazilian company, and I am instructor of the malware analysis courses, fundamental courses, and we have their penetration test courses and something like that, right? And I am a writer and reviewer of these magazines, and Pentest magazine, Hack9, and a forensic magazine. So this is information about me, right? So let's talk about our summary or our agenda, right? So first we understand who is a threat, because I would like to put all those in the same page, right? I think it's very important. And after that, we gonna talk about more analysis, and we need to understand, we go to understand about the structure of the PDF. I will do the demo in the end of this explanations. In the end, if you have any questions, I will hope to answer to you, right? So who is threat? It's very important thing here, because in security, we have many different explanation or, about this word, a simple word, right? So I just chose one of this, right, based on according to this ISO, right? So threat is a definition, has a potential cause of the incident that may cause harms in the system and organization. And here we have an interesting point. Maybe threat can be, it's a software attack or a theft of intellectual property, identity theft, or sabotage, or no, and information extortion are example of the information security threats. As a result, most of the many organizations chose active threat hunting to practice to defend their organization from the network no threat. So that's a good point here. So maybe you can think now, so Philippe, so actually the threat is almost everything. Maybe as, of course, related to a softwares or attacks. Of course, we have a physical attack as well. So in this case, is almost different, but in the end of the day, the concept is almost the same, right? The attacker will, attack something, a software or a people, right? That's an important thing here. So the first step when I will execute some analysis, the first idea I have, of course, I have a sample, because I don't know if malicious or not, right? So I have a sample and I need to analyze this. And the first step and the first idea is to identification step, because I have a sample. I don't know if it's malicious or not. I don't know if it's a malware or not, or it is, I don't know, it's document malicious or not. So this is a simple definition, right? Malware, it's a malicious software, and maldoc, it's a document malicious. So when I identify this sample, I can choose what the best method that I will apply in this binary, for example, or this file, right? So I will use an static analysis or dynamic analysis, right? This is just a concept. After that, I will prepare a report, because this is a very important step, because when after this, I execute this analysis, I can prepare a report, because of course, this is part of our job, right? Or part of the rule of the analyst or the threat hunter or something like that. So this report I can present to my manager, to my tech lead, or wherever. But I can explain all those steps that I executed when I made this analysis, right? But Philippe, if I have a report, what can I do with this information? So the next step is very important, because I can improve the defenses mechanism. Because at the end of the day, when you do this analysis, you can improve your defenses mechanism, because you will discover what kind of steps or way the attacker used in your environment. So if you see that attacker maybe using the bypass technique to exploit your firewall, for example, you can do different, you can improve the better configuration, you can use another different, or the best practice, you can see the configurations on the settings in your tools that you use or the product that you buy, for example, right? So after that, you can create the good word, the cyber threat intelligence, you can build it. It's very interesting, because so if you have a small company, maybe it's impossible you create the cyber threat intelligence. But today we have many different softwares or open source products that can help you to build it, and why you can create, or why you could create the cyber threat intelligence. Because if you learn how this behavior of the attacker, of course, you can prepare more your defenses, the mechanisms. This is very important here. And of course, because the cyber threats or we have a training in cyber resilience, we need to have this, because during our presentation now, probably we have another guy, another attacker or a threat actor creating a new different attack using a different techniques, right? Because of this, we have this life cycle, not life cycle, but the cycle of the attacker phase, right? So you can use in this method. So let's talk about statistical analysis. So what is a static analysis? So it's very interesting. Usually this is the first step that the analyst is using, because usually the statistical analysis describes the process of the analyzing a program code. It means you have a code, you can analyze all those parts of this code, if part of this code is malicious or not, or you can analyze the structure of this code. If inside this code we have a structure, if this structure has called some function, for example, you can find a DLL, what function this DLL is calling inside the system operation, for example, and the program itself doesn't run at this time, right? Of course, depending on the program that you can use, but usually it's this method. It's more safe, right? Because, as I mentioned, doesn't run at this time. You using like a manual command to try understand of this code, right? And when you talk about the dynamic analysis, it's another part, another different method. Usually, it's based solely on behavior. It means in the interaction that the malware has when it's executed, or maybe a malware or maldoc in this case. This analysis, also known like a runtime analysis. It means you execute the malware inside a controlled environment, right? Or not controlled environment, but can use some tools or product. Maybe you can execute this malware inside this product, this code, not code, this tool. You can analysis of the behavior inside of this controlled environment, right? So it can be easily automated. There is main sites today that already perform analysis of this malicious artifact, right? So using a small concept called a sandbox. It's similar. You have a virtual machine, and you execute this malware inside this virtual machine, and after that, we will see all those behavior this malware has inside this virtual machine, right? So let me see here. Yes, before talk about the physical and logical structure, I would like to share something here with you about the base, because it's important. If you remember in the beginning of this presentation, I talk about the identification step, right? So the idea here is to try to understand about this point. So here I have many artifacts, right? I have an Amazon, I have a view, invoice, I have a Linux, I have a PDF. This is a folder, not a file. And I have here read pil docs so. And so I have many different file here with different extension. So what command I can use here to try and find any information about this file? So I think many people know about this file command, right? So I can execute malware file command to try identify what this sample is, right? So here I have an Amazon, Microsoft Words, right? 2007. Let me try looking inside another, for example, view. It's a good friend. View, it's a PDF file, right? So let me see here about the Linux doc text. Maybe it's a text. So in this case, it's not a text, it's a ELF file. So it's different here because I have another interpretation here. So let me see another file, resume, about PDF. It's a PDF, perfect. So let me see here in a Windows. If I have another here, I have a sample file, sample. So here I have a PE32 executable, right? So as you can see here, I execute a file command. We have a identification process, but we have here some interesting point, because I execute here file Linux doc text, but actually it's not a text file, right? It's executable file. So how it's possible? Because here we need to understand about the base. That's my point here. When you execute this file command, in this case, file determine the file's type. But what is actually the correct information that this command are using when executed in your environment? So here it's the manual. I know probably you don't like to read the manual, not not only in the Linux platform, but you don't like to read any different manual. I don't like, by the way, but I suppose that you don't like, right? So, but here we have important information to understand the base, right? Here we have important information. So let me explain more about this. The magic tests are used to check for file with data in particular fixed format. So probably we have a specific format to try find or to understand what kind of file is. It's not, of course, not based on the extension, right? And here we have the explanation. This file has a magic number. Here is the key, right? So all those files has a magic number, right? So this magic number, right, is stored in a particular place near the beginning of the file that tells the Unix operation system that file is a binary executable. So here we have a simple and very important explanation. So all those file has a magic number, right? And all those magic number are stored in particular place near the beginning. So, but how it's possible to understand more this? So here I made this very interesting thing to try explain more about this magic number for you, right? So I downloaded the file command, not a file command, I downloaded the database responsible to offering this information to the operational system. Of course, when you have in the Unix platform, as you can see here in my machine, I'm using this binary is compiled inside the system operation, of course. In my case, here I downloaded this source code, and I download the database of the file command right here. So let's see very interesting information here. Let me looking more inside the JavaScript. So here we have the file of the JavaScript, of course, and we have the definitions, some definitions important when I execute the file command, and this file command looking inside the database to try find the magic number of the JavaScript file. For example, let me put here this information. I will copy here, and I create in this simple file here, PDF doctext, right? And I will write here, and I will put the information in malware. Now, actually, I will do the different. I will put just a malware, right? And I will save, and I will look the PDF, right? Actually, it's a text, as you can see here, right? It's a text. But now I will change this information in the beginning because I learned now, or I read now this in the man of the file, that all those file has a magic number in the beginning, in the particular place, right in the beginning of the file. So I will save here and the note. When I execute the file, take a look what happened. This is of course, is a text, but in this case, the magic number, it is identified by node.js script. Take a look. I will change another thing here. I will put just a simple sign here, and I will save again, and let's see what happened. Ooh, it's a Python script. Very interesting. So let's change something here. It's a PDF, move to PDF.py, and I say mode.pdf, PDF. Okay. So, yeah. Let me change here the privilege to PDF, right? And let me look again. It's a PDF, right? So let me call Python here, Python 3, a PDF here, and bam, we have a syntax wrong error because it's not a Python, right? It's very interesting because It's not a Python, but if you see in the beginning, so let's see here, cat Python. Take a look here, the some regex. Because of this, because I put here the magic number. As you can see, we have a different here, different information like similar regex. You can have a regex. You can see the informations here that you can use here. For example, let me copy here, and I will change one more time. Here, it's a Python, right? It's a Python. I will cut here and I will save. As probably you see, in this case, in ASCII, I'll take a look. It's very interesting. It's in this case, it's different because probably we use just only like a policy inside the database, right? Not a policy, actually. It's one of this rule. I think it's better this rule, right? So let me change the one more and the last time here. Yes, it's no. I will cut here. I will put the % PDF because this is our challenge here today. And I will save here and let's see what happened. Whoa, it's a PDF document, but indexation, it's a Python. So all those, so I did it during this presentation. Basically, let me talk with you. I did it during this presentation because you need to understand all those bases. As I showed during this presentation, you see here, we saw here actually the file or the identification step. It's very, very important, right? Because you need to understand inside of the file. Probably you know about the file command, but the idea is here is it's try to explain you how it's important to understand all those bases, right? Because, for example, let me share my screen one more time with you here. So let's look inside this one more time here. I think you know, but probably so. Maybe some people don't know right here. Let me look inside this mod here. We have here another interesting, very interesting information. Here. Okay. Whose format, or in this case, the magic tests are used to check for files with data in particular fixed format, right? I already read it. The canonical example of this binary is a binary executable compiled program because it's inside of the system operation, right? And h.out file, whose format is defined in elf.h. Here's another format, and possibly execute.h in the standard included directory. So let's see, because here I can see, I will copy this format, right? So let's see if you, let me return malware. Yes, locate this file. Let's see. So this binary actually, it's included, it's in this path, user include elf, right? I will read here. So, take a look what is important here. This file, I think you can read. This file defines standard elf types. So take a look what is important inside this file, right? So this file defines standard elf types, structures, and macros, right? So here we can find the correct structure of the elf file. If you read below, if you see here, you can see the number of the bits used, right? The words, X words, and here you can see the interesting information. The elf file headers, I know this presentation it's about PDF, but take a look about the man or the information that we found it and then we found it inside the map. The elf file header better, this is the file, the ELF file header. This appears at the start of every ELF file. It means appears at the start, not ever, start, that is in the beginning of the ELF file. What started in the beginning in this case? We have in the beginning of the ELF file, we have 60 bytes, right, or bits in this case, and we have this structure, 60 bytes, right? And the first array of this bytes is called e-ident, and you will find the magic number and other informations inside this 16 bytes. We will find all those informations. You see? So magic number and others information. What kind of information? You can see. Here, let's see. Okay, this field is fields in the e-ident array. You will find you can find the file identification byte. The first is 0. The second file identifier is E. The third is L. In the 4 it's F. I will show you another thing to you here. Let me open. You see file Linux 32, right? And let me using file. I use a file, right? And if I use here XD and 32 Linux, right? Okay, no, it's not Windows, not Windows. Yeah, now it's correct. So take a look here. The 4 bytes, the first is 0. The second is E. In this case, it's E here, as you can see. The third is L. It's L here, right? And the 4, it's L. You see? You can see. So that is important. You need to understand this because I read the man of the file and I found many information important of the structure of the file. But if I didn't read this information inside the man, you know, how it's possible to understand the basis? Of course, I need to run, I need to study, I need to read actually. I need to study about all those bases. It's a main point here when you talk about the malware analysis, when you talk about the red teams, pen testings, defense team like a blue team, or threat hunting teams, or SOC teams, or whatever teams. You need to understand all those bases, right, people, right? So let me return here my presentation, right? Let me return here the structures, right? So let's talk about the physical and logical structure about the PDF. Usually we have 4 parts. The header, usually it's very common in wherever binary. We have a body, we have a cross-reference table, and we have a trailer, right? So this is the main part of the PDF. In the beginning of the file, we have a version number, right? And you have objects, you have images, you have a cross-reference table. This is a location of the object inside within the file because it's random, right, the access. And we have a trailer. It's a location of the certain objects inside the body. It means you have a mainly body and you have many objects inside this body, and all those objects is or are in this case are reference one and another, right? So let me show you the demo to you. So I will use here some tools to help us in this demo. I will execute the PDF ID. It's very known tool. It's created by DDA Stevens, right? and I will execute this in Linux. If you see here, the first information that we found in this demo, as you can see here, we found the header, as I mentioned, the structure, right? So the second information here, we found the 15 objects, right? So we have 15 objects, and of course we have the same 15, right? So maybe you have here, not maybe, you have two and extreming, because we have a two extreming, and here we have a cross-reference table. And if you see here, we have others important informations, of course. All those informations are inside the DDA Stevens blog, right? You can find all those explanation more inside the blog page of the DDA Stevens, right? But here, the slash or slash page, slash encrypted, slash object streaming, slash JavaScript, here we will find interesting informations. All those informations are inside this mainly part of the PDF. So here I have an important tip for you. Probably when DDA Steven created this tool, he studied a lot about the PDF structure, and of course, he analyzed probably many malwares, and he found many information inside this samples. Yes, and when probably, of course, I'm supposing, because I'm thinking the idea of the basis, right? So all those slashes are information inside the main point, the main object, and these tools only just will possible to create it because probably the DDA Steven, the main creator, right, knew about how this tool works, right? Or not tool, but how this PDF works. It's the main point here, right? So let's continue to see here. And we have here one page, and we can see here we found 5 JavaScript inside the PDF, and we have an open action. Open action is a very interesting point here. If you read in the website, if you read, of course, we will see the open action is responsible just the user don't need to click many times in the PDF file. When you have this open action inside the PDF, the only action that user needs to do is download the file, for example, from the email. If user receives an email and click in this PDF and download in for example, in the machine, in the Bitman machine or in the own machine, because they have this file has an open action, when the user download this file will execute this open action. In this case, it will execute something inside the PDF, right? So I can suppose, of course, if have an open action, and if have JavaScript inside the file, and this file just have an only page, and we have some information encrypted, probably it's malicious, but I don't know exactly what is malicious, but it's malicious. I will execute after that the PDF parser. It's another tool created by DDA Stevens. I set the run because I would like to see all those information inside this PDF. And here I will explain something to you. As you can see here, the header. And after that, you can see here the object 1. And here we have object 1, say catalog. And here we can see the referencing. Here's a very interesting point, because the object 1 is referring object 2, object 3, object 4, object 5, 6, and 7, right? And what this means in this case, here it's an interesting point. Do you remember when I explained about the structure? If we have the object, the body. Inside the body, we have objects, reference, or inside or located inside the file, right? So many times no, but all those files or those objects are reference one another, as I will show you here. So take a look. In object 1, we have a JavaScript, and we have an open action. Let me return here. We have an object. In this first step, it's an open action. is these open actions, after this action executed in the victim machine, is executed or will be executed a JavaScript. So here there's evidence that is malicious, because the user, when downloaded the file, after that will be executed an open action, and after that will be executed the JavaScript, right? So let's continue to see. So, okay, we have an object 2, 3, 4, 5, and take a look here. Let me return one more time here, because I have here another information, important information here. Okay, take a look here, object 4. In this case, object 4 references object 8 and 9, because before we just have an object 1 until 7, but now we have an object 8 and 9, 2 more objects, right? So let's continue. In object 6, 4, and here we have another reference. Object 7, we have another reference. In object 10, and inside the object 10, we have a JavaScript. You see? Okay. So, and here, let me put, in object 9, take a look what happened here. We have an object 4, because, you know, we have this reference between the objects. And here we have another reference, 11, object 11. So we have a beginning, this is the 1 object, and now we have the 1 until 11, right? But when we executed the PDF ID, do you remember how many objects we have inside this file? 15. Don't forget this, right? Here, take a look. We have the object 10. Inside object 10, we have another reference, object 12, right? And we have probably here we have a JavaScript. Okay, take a look here. In object 11, we have here we have another information, different contains a string. So probably we have something inside this string, right? And when we have this flag the code, because we need to decode the information, right? And here we have a length. It's like a size of this kind of string, right? So maybe when you see here the size, it's small, okay? And inside of object 12, we have another reference in object 13. And inside this object 13, we have a what? A JavaScript. So let's continue to see what happened. And here, take a look. Contain string in object 13, and you have the same flat decode, but here we have a big size, 3151. It's a big size, right? So here maybe I need to look in more deeply, right? So okay, and we have another object 14, the last, then maybe almost the last, right? And because we have 15 objects inside here, and we have here the object 15. Okay, so we need to see more deeply of the 13 objects, right? So next step, I will execute a PDF TK. It's another tool. Actually, this tool is not from the Steven, but it's another very interesting tool. I will basically here the command I will execute. I will collect the output of this sample, all those information, because I will extract of this information here, and I will uncompress all this information inside this dump doc text, right? Okay, I will execute this. So now we need to see what information we have inside this dump, and take a look what we will see here. I can see all those information, and take a look here. Here we found the first technique used by the attacker. So here we can see the JavaScript obfuscated. So what the next step? I need to disobfuscate of this information, but here the attacker used this technique, right? So I will see here some informations. I see some parameters that the attacker used in this demo, in this case. So I will copy the code, and I need to, of course, disobfuscate this code to try find some information, right? So I will set this file in HTML. Why? Simple, because when we execute any web applications, usually they use in the JavaScript and HTML and CSS and something like that, right? So I found here the evil parameter, and I will using this evil parameter to try to disobfuscate this code, right? So basically, I will see inside this parameter, and I will change to the document writer, right? Because document write actually, because I will need to, the idea here is to try read what information I can find inside this JavaScript obfuscated, right? So take a look what happened here. It's very, very nice what happened here. So after that, I gave the privilege access to access this information, of course, and I will execute this payload.html. So take a look now what happened here in our demo. Wow. I will show you. I will found the var, a variable payload. As you can see here, we found a payload, right? So what means exactly in this case? We found here a payload malicious. So first of all, we have a PDF file. Inside the PDF file, we have an open action. This open action, after that, will execute the JavaScript. This JavaScript to us, what? Obfuscated. Inside the JavaScript has a payload. Payload is responsible to, load this payload inside the virtual machine, and this code is responsible to call back to the CNC in this case, right? So now we have a payload responsible to, load this information or to download this information, actually, to download this information inside the virtual machine. And this payload, in this case, this payload, as I'm showing to you, will be responsible to call to the CNC from the attacker or the threat actor. So now I could to finish my analysis, but here we have an interesting point. If, let's suppose, if I have the payload, I can try to find this IP responsible to this attacker, right? So after that, what I see. So let's see what kind of information I can try and find. So I see here some information, right? Like a percent here and some numbers maybe. So the next step, I created another file here, right? I called it real payload. Perfect. And I would generate, I copy and paste all those information inside this file, and I using the set to cut this percent here, because my idea here is to try to clean the file. Take a look here, the var, the parameter, and I cut some information, and here I cut many others like a slash, like a percent, and I copy this information, and I arrived in a Unicode code here. So now I have this Unicode code. It's another technique, because the attacker in this case uses it. It's, of course, it's not new, but it's old. The Unicode code based on UCS. Yes, actually, UCS. Yes. No, EC2 UCS. Yes. So it's Unicode. It's based in 2 bytes, different of the ASCII. It's because ASCII is very common now. So this is here. It's very interesting. So I use in many Linux platforms. So I will see now another platform, Mozilla, in a Windows machine to show you. So here we have the same code, right? So we have aquí all those percent here I need to cut that I did in the Linux machine, right? So I cut this information, and here I have the pure, pure Unicode. So after that, so do you remember I had a JavaScript obfuscated. I just obfuscated this code, and after that I generate a payload. This payload, I found the Unicode code base in UCT in UC2, sorry. And inside this information, I generate an Hexafile doc binary using this tool, Mozilla, right? So after that, take a look what I did. I using a short search, it's another tool provided by DBA Stevens. I execute an Hexafile, my file that I generated here, in this case, and I called HTTP protocol. And take a look here what I found. Basically, I found the CAC from the attacker. You see, this attacker was, in this case, in Estonia, Europe, right? So now we finish our presentation, and I will show you here my contacts again on the social medias. And just to finish the presentation, so let me talk with you. We had a sample because we have a PDF file. So we found a JavaScript inside the PDF file. We have an open action. We had an open action inside this file. This PDF had an open action, and this open action called a JavaScript. The JavaScript has, or had in this case, a JavaScript obfuscated. Inside this JavaScript obfuscate, we had a payload. This payload, it will be downloaded on a Vitman machine, right? And this payload has a Unicode code, right? It's old, of course, but it is another technique. And after that, I generate a hexa binary, right? And after that, I use Ensure to collect the HTTP protocol to find the CAC from the attacker. In this case, a command and control, right? Responsible to set or to send this attack to the Vitman machine. So we finish our presentation. If you have any questions, so please let me know. I am available to you. Thank you one more time for stay with me during this presentation. So again, if you have any question, I am available to you.
Hello everyone, and thanks for joining me at the Red Team Village. My name is BitK. I'm a bug hunter and CTF player with the Flat Network Society. We were the winner of last year NahamCON CTF. And my specialty is about web exploitation. I'm also working at YesWeHack, and I've been doing a lot of open source projects recently. For example, YesWeBurp, an add-on for burp suite that allow you to import your settings from YesWeHack directly into burp. CTF Note, a tool for CTF players that help them manage their team and collaborate. And Poonfox, an add-on for Firefox that facilitates the pen testing of application with multiple profiles by allow you to do compartmentation. I'm here today to talk to you about XSSs. Why talking about XSS? First, I think XSS is one of the most commonly found on bug bounty program. I think every bug bounty program, in the activity of the program, there is at least one XSS. Why? Because a lot of hunters are looking for them, because it's quite easy to understand and quite easy to check if the bug is really there. You can just try and inject some HTML. If something triggers, that means that your XSS is working. And also, it's very common because it's difficult to identify and to protect yourself against it. If you have a user input, you don't need to escape it the same way if it's in a HTML context or in a JavaScript context. There is also a lot of DOM-based XSS, and JavaScript being JavaScript, there is a lot of weird thing going on that can lead to XSS. The second thing that got my attention is there is a large payout diversity between XSS. On some program you will get paid $50 and on other $5,000. But even on the same program you can see XSS ranging from very low payout to very large. So why is this? I think XSS is often underestimated by program manager and developers. And why is it underestimated? I think it's because most of our POC, when we submit a report, do nothing. Usually we only use an alert just to prove we are able to run JavaScript, but we stop there. And I think because of that, the idea of an XSS for developers is only, oh yes, an attacker can start an alert box, or an attacker can steal my cookies. But they don't see the full impact that an XSS can have. For example, I've seen programs where XSS were out of scope, but CSRF were in scope. And that's a bit ridiculous, because with an XSS you can do basically the same thing as what you will be able to do with a CSRF. So how can we help program manager and developers to better understand the impact of such bugs? We should write better payloads. But writing better payloads can be very time consuming, and if you are doing bug bounty, you know that time is often the key for a report being accepted or duplicated. It's often repetitive. You don't want to spend a lot of time every time writing an exploit that will fetch something like a token, a self-serve token, create a form, update something on your profile. It's a lot of work, it's often the same thing, but it's also always a little bit different, so you cannot really reuse your payload every time. And there is a lot of pitfalls to avoid. For example, you will have payloads when you need to encode, URL encode your payload, and then HTML encode, and then something else, and somewhere in the middle you forget something and nothing is working anymore. You don't know why, and it takes a lot of time in debugging and making everything work again. I will show you how I used to write payloads and how it was inefficient and how I get stuck all the time because of encodings or double quotes going somewhere I don't want to and breaking all the payload. Because of all the CTF I've played and all the bug I found that was XSS, I think I started to get bored of writing always the same thing over and over. So I started working on a library to help me write more efficient payload in a shorter amount of time. I came up with XSS tools, a tool inspired by Poon tools. If you've been playing CTF or writing exploitation, binary exploitation, You already probably know puntools. It's a set of functions that will help you write your exploit. So I wanted something similar, but for XSS and other kind of client-side bugs. You can think of it basically of a jQuery for XSS. It's not required to write payloads, but it will help you to write them quicker, and it will already include all the most common functions you will use when writing on XSS. One of the plus side of the lib is only required to write the exploit. That means you need to run it on your computer, but after that the exploit generated with the lib will run as a standalone exploit. Enough with the slides, let me show you some real examples so you can better understand what I mean. To do my demonstration, I will use the public firing range by Google. It's a website vulnerable by design, when you can test your XSS payloads and check if everything is working as intended. For the demo, we'll use a simple injection, a reflected XSS in a parameter body. This is the most simple way you can do an injection. Let's just test it in the URL. Okay, so we have our title. This page is vulnerable to XSS. What are we going to do? We are going to try to write a payload that when the payload is triggered, it will fetch the index, read the title, and send it back to my server. This is very similar to something you would do, like fetching, for example, a user token or a CSRF token or something like that. So this is how I use to write payloads. So what is the goal again? We want to fetch slash, read the title, and send it back to the server. But first we want to be sure that everything is working as intended. So we take the URL and build a small payload. We just want to do an alert and test it. This whole code is wrapped in the Go function, so I need to click on this button to trigger it. Let's see what it looks like in the browser. Here we can see the button Go, so let's click. We are redirected to the firing range and the XSS is triggered. The alert one is showing here. But now we need to complete our goal of fetching the title and sending it back to the server. So I've updated my payload. Now it's fetching the slash, read it as text, then use the HTML in a regex to extract the title. And when the title is extracted, it's send it back to my server using fetch. If we try to run this payload again, we get an error, and this is quite obvious why. Because our payload is no longer a single line, it breaks the HTML syntax and nothing is working anymore. So we need to fix that. So let's go back to the payload. I tried fixing the payload by replacing the double quotes by the HTML representation and removing all the new lines. And on top of that, I'm wrapping the payload inside double quotes. So now it should be working. Let's test it on Firefox. Okay, once again, it's not working. Why? It's a invalid regular expression flag T. So why is that? Let's look at the code again. If we look at the code, the bug is just over there. Because we don't want the slash to be the termination of the regex, we use the backslash. But this backslash is escaping not inside the regex, but inside the string inside our function Go. So we need to double escape it, and now we can try again. The payload is bugging because we use the regular expression over there, and to make it work we had to escape the slash. But here the slash is not escaped in the regular expression, it's escaped in the backtick. So we need to double escape this. We also need to add some semicolon to separate these two lines, but finally the exploit should be working now. Let's click on the go button and see if the payload finally works. Now we can see that the request to slash has been made and the title has been exfiltrated, but the request has been blocked by cause. So let's do one last patch to make everything work for real. To avoid getting stuck in course error, I just added this option to fetch with mode no cause. This way the browser won't send the cause pre-fight and just send the request without the need to read the answer. So let's test this final payload. And we click on the go button for the last time. We can see that the request to slash has been made, the title was exfiltrated, and there is no error anymore. So now the payload is working. But it was a lot of back and forth between testing and writing the payload. There is a lot of ways this can go wrong. For example, if there is like a comment in my code, putting everything on one line can break everything. So depending on the payload, we cannot just reuse the encoding parts. And this is how I write my payload now. So first I define an exfiltrator. This will be the part of the code responsible to exfiltrating any data back to my server. For this demonstration I used the first exfiltrator, that is get, so it will do a get request using fetch on my domain using the exfiltrate parameter. Then I create a payload with payload.new. I add my exfiltrator to the exfiltrators list because I can use multiple of them. I ask the payload to fetch slash as a DOM element, so it will return me a document element of the main page of the index. Then I use query selector on this page. I look for the title tag and I get the inner text of the tag selected with the query selector. And then I call the exfiltrate function that will loop over all the exfiltrators and exfiltrate the data. But this only gives me GS code. So now I got some GS code. I need to wrap it in some kind of executor. Like before, we wrap it in a svg load tag. And we call the wrap function on the wrapper to get the final payload. To display the payload, I use some utils function available with the template I will show you in a bit. So a log, just to send some message to follow the execution. Then I build a URL. It's a simple URL builder taking an URL and an object for the get parameters. And then I append the frame in the template. Let me show you. This is what the template looks like. It's divided in two parts. On the left you got the console for debugging purposes, and on the right the list of frames you've opened. Here we've opened the firing range, but it's blank on blank. But you can see in the request that the frame was opened here without payload. Then a request was made to the index, and then the exfiltrate function was called. The data is sent as base64 to avoid any problem with encoding during transfer. If you don't have a server but you still want to prove that you're able to exfiltrate data, you can do it only on the client side by using post message to prove that the frame that is being exploited is able to communicate with the top frame. Let me show you how to do this with XSS tool. Instead of using the get exfiltrator, I will use a simple post message exfiltrator to send the data from the exploited frame to the top frame. I can put another frame name here, but by default it's top. Let's see what it looks like now. This time when the payload run, instead of sending the data back using a get request, the data was sent back using a post message, and we can see it here displayed in the console. So this is a good way to prove that you are able to steal data from a remote server without the need to have your own server. This is a fairly simple payload, but XSS Tools is way more powerful than that. Let's build something better. On top of what we already have, let's add a keylogger and a click logger. So let's start the click logger first, and then we start the keylogger. Automatically, these two functions will call the exfiltrator to exfiltrate the data, but you can submit your own function over there if you want to do something else. Let's use the exfiltrator first. The exploit looked the same, but now if I click on the page, I can see that the position of my click and the HTML elements under the click are exfiltrated using the exfiltrator. Also, if I type on the keyboard, all the keystrokes are sent back to my server. It's easy to deploy, and I didn't have to modify anything in the wrapper. That means now all the payload code and the code responsible to wrap everything and make everything execute are totally separated. I can update one part without touching the other part. So how those XSS tools works? XSS tool payload are written a bit like shell command. Here we can think of this payload chain as something like, first we call new to create a new payload, then we add our exfiltrator that we've created before, then we start the click logger, following by the keylogger, then we fetch the DOM /. We use query selector on it to get the title, and we take the inner text of this title, and then we call exfiltrate. So this is very similar to a shell command if you think of using dot the function as a pipe, because every command output will be forwarded as an input for the next one. Let me demonstrate using a more complex payload with XSS tool. So we start with a fresh payload. We just add our exfiltrator. This time we still want to fetch the DOM on /, and we will try to get all the link on / and get the URL of the link and exfiltrate this. This is a good way to discover hidden website if the XSS is blind, for example. So I will use query selector all. I will look for all the links, and I will get the href element. Then for each of these elements, I will create a new payload, and I will call exfiltrate. Now when we open the page, the XSS will trigger, fetch the index, and send us back all the links. You can see here in the console that all the links and all the href attribute of each link have been sent back to my page. XSS tool come with a large choice of already available function that will help you build the payloads rapidly. Each function come with an example and a little bit of graphic to show you how the payload behave according to the pipe system on XSS tool. You can find the documentation with the source code on the GitHub. But if you are already very familiar with JavaScript, you might want to write your payload by yourself and only use the wrapper function. This is still possible. Let me show you. If you don't want to use the function built-in, you can always create your own using eval. That way you can do complex operations that are not pre-offered with the tool. I don't know, for example, accessing the local storage or stuff like that. You can always use eval. If you return something, the return value will be put in the pipe and will be usable by the next function. For example, here I can use another eval, and let's multiply the value by 2, and finally let's call exfiltrate on it. Here we can see the payload triggering and sending back the 84. That means you can write your code either using XSS tool function or your own, or even mixing them to build something that suits your need. Now that you're able to build your payload efficiently, let's talk about wrappers and how you can deliver those payloads. Until now, all our payloads are executed using the svg load function. This will build a payload looking like this, svg onload and the payload here. But sometimes you are not able to use the on event triggers because they are blocked by a WAF or they are simply not available in the char set you have. So maybe you want to use something else, like just using a script tag, for example. This time the payload will look like this. But this doesn't always work, because if you are in a context where the payload is injected using inner HTML payload, this won't work. The script needs to be parsed as a document element. To do so, we can wrap the payload in an iframe, for example, with an SSEDoc and the payload inside of it. To do that, you simply add a new wrapper to your wrapper chain, let's say iframe, and now the payload is wrapped like this. But if your input is not injected in an HTML, for example, and it's injected in JS, and you want to use document.body append child, something like that, with this iframe, with the script inside of it and everything, you can just continue to chain all the wrappers and build a very powerful chain of wrapping. This might look useless because you might say, oh, why would I want to wrap an iframe inside a script, inside a document body and everything? It can be used to bypass WAFs. I've been able to bypass Cloudflare WAF using something similar and get an XSS on Starbucks, for example. When the payload trigger, it will create a frame in a frame in a frame that will load our JS code. So we can see all the frames here. We can see the code is still executed and we got the callback. Let's take a closer look at the source code of this frame. We can see here our injections. So we have the iframe SSEDoc inside an SSEDoc, inside an iframe, inside an iframe, inside a template function, and here is our code using no parentheses. This is very powerful because you can totally separate the effective code you want to run and the way you will be running it. Once again, the documentation for all the wrappers is available with the source code, and you can see for every function what it does and how it can be used, and a simple graph to know what is the output of each function and how you can chain them and use them in a payload. If you want to use the wrapper but you don't want to use the payload generator, you are always free to use the wrapper with a string instead of a payload. For example, here I will just want to call alert1 as a payload, but I still want to use the previous wrapper that will do minify, template string, script, iframe. Let's test this. Once the page loads, you will see all the iframe and the alert trigger. This means the code was executed properly inside all of our wrappers. This is good because that means if you want to use only the wrappers from XSS tools, you can. If you want to only use the payload generator, you can. You are not stuck with the whole frameworks, you can only use what you need. XSS is not the only bug on the client side. You can also find some clickjacking on websites. It's easy to find when it's there, but it's often difficult to exploit because you have to make everything line up perfectly and it can be very fastidious. Here I've built a small example using the XSS from before. So I will just load the page and I will just add a button. When it's clicked, it just shows an alert saying OK. But you can think of it of, for example, a reset password button or delete accounts button. This is what it looks like in Firefox. We have the frame with the button, and if we click, we got an alert. Now we want to trick our victim into clicking on this button without knowing about it. To do so, I've created a new clickjacker class. I've given the clickjacker the URL of the website I want to clickjack, and I've added a step. Each step is a button you want to push. Here I put the X and Y coordinate of the button. I can put a width and height, so it will be automatically centered. And I can call clickjacker.run. Let's see in action what it looks like. Now, when I open the page, I will be greeted with a pop-up, but if I click on the button on the top right of the pop-up, the click will in fact trigger on the hidden frame, and the alert text box will be shown. Here you can see. That means that the click didn't happen on my page, but on the targeted web page. This time there will be 3 buttons on the page, and they will need to be called in the right order for the payload to trigger. So I've added 2 extra steps on my clickjacker, and I call run once again. To trigger the alert, we need to press the button in the right order. If we do it in a different order than 1, 2, 3, nothing is happening. So let's try 1, 2, 3, and we got the OK page. Let's see how the clickjacker handle this. So I will refresh the page. I got a pop-up open on me. I can click the first one, the second one, and then the last one, and the alert trigger. So this worked very well even with multiple steps. Usually you are not able to catch events happening on an iframe, but what I did here to make this work is basically I have a hidden field with the focus, and I wait until the field loses the focus, so I detect that the click is happening outside the frame. So this lets you use a multi-click payload for clickjacking in a very, very simple way.
right. Welcome back, everybody. And thank you, Jasmine. Thank you for supporting us here today. So we have our last workshop of today. Today has been a successful conference. I would like to thank everybody that is actually participating pretty much everywhere, in the villages, at NahamCON, and everybody, especially the speakers, right? So the next workshop is what is under that thing, learning how to reverse engineer an Android app. And without any further ado, I pass it back to Jasmine.
Hey everyone, I'm so glad that you're joining me whatever time zone you're in around the world. So thank you for joining me. So without further ado, let's get started with the workshop. So I guess I should preface how I do my workshops. Half of it will be theoretical, where I go over, the topics, and then the final half will be where we do a bit of application. So let's get started. Okay, as Omar said, the title was under that thing, learning how to reverse engineer an Android app. So a little about me. Who am I? Well, I'm a California native, from the Bay Area. I currently live in Charlotte, North Carolina. I have my master's in computer science, a graduate certificate in information security and privacy from the University of North Carolina at Charlotte. My base is in application security, but I'm interested in all aspects of security. And if you want to connect, my handle is bfluffy007 on everything, Twitter, IG, YouTube. I just started a YouTube maybe like a month ago, and I have like one video, so bear with me, I'm building that out. And I also have a blog at thefluffy007.com. So what is the goal for this presentation? The goal is for participants, you guys, to have a better understanding of mobile security and have the tools to continue further learning. So I just want to level set about, you won't be like a guru, but it will give you the base to continue on in mobile security if you so choose to, and I hope you do. So before we start talking about what's under the hood, let's look at a few mobile security case studies. So from Threat Post, there's the first case study I want to highlight. Financial apps are ripe for exploit via reverse engineering. So as many of you know, with your cell phones or your smartphones, you might have, your banking app like Bank of America, Wells Fargo. Well, white hat hackers found that 30 financial apps that were reverse engineered, sensitive information was exposed. Sensitive information like PII, or personal identifiable information, such as your social, your bank account, all the things that could be tied to you. Also in that study, 97% of Android applications tested lacked binary code protection. So what that meant was that Android applications could be decompiled, or you can look under the hood. And so this is problematic because you can modify these applications, right? As when you reverse engineer, and you can learn the functionality and the logic behind it, you can modify these applications for nefarious reasons. So case study number 2, thousands of dangerous Google apps were found in the Google Play Store. So for Android, the official repository is the Google Play Store. So what was found was there were thousands of dangerous malware apps that were found on the Google Play Store, which again is the official repository for Android apps. And this was done using a neural network to review 1.2 million apps. So what they found was a little over 1,500 counterfeit Android apps had at least 5 dangerous permissions. And we're going to talk about dangerous permissions a little later in this workshop. But to put that in perspective, over 2 billion devices run this mobile operating system every month. So again, even if you're thinking, hey, I'm going to the Google Play Store, that's the official repository, I should be safe. that's not necessarily the case. There are some apps that could slip through the cracks, and you still have to be very careful and vigilant to make sure you are downloading the correct app. And then finally, the last case study was just over a month ago. Google had a patch over a dozen high severity privilege escalation flaws in Android. So the latest bulletin, which was last month, February 2021, 40 vulnerabilities were remediated. So, and these 40 vulnerabilities, Google had to patch an information disclosure flaw, which disclosed sensitive information in the Android runtime. Now, that might not seem, it's like, okay, the Android runtime, why are you highlighting this? Well, the applications and system services use the Android runtime. So essentially, it's any application or any system service could be susceptible to this information disclosure flaw. And again, it had a high severity rating, meaning it had to be fixed pretty quickly. So I showcased this security case study to show even last month, there's still vulnerabilities that come out that still need to be patched and remediated. So again, we have our smartphone devices, and it's so easy to be like, oh, I want to download this app, I want to use it, but you have to be super vigilant to make sure you're downloading the correct thing, because if not, nefarious people could have your data, right? And your smartphone holds a lot of data. It's a mini computer. So I guess the next question, are apps secure? So the answer should be, after looking at this, not really. So I like this diagram from Now Secure, and it pretty much lays out the threat vectors for mobile attacks. And as I said before, your smartphone is a mini computer. So you have really three areas of attack. You have the physical device itself, you have the network, because when you send and receive data, it's using a network. You have the cloud and center, so like a web server, a database. So with mobile devices, you have a much larger attack surface to actually, compromise your device. So you have the browser, you have systems such as Android rooting or iOS jailbreak. We'll talk about the Android rooting in a little bit. With the actual apps, with like reverse engineering, sensitive data storage, escalation of privileges, that network, if for the Wi-Fi, if there's no or weak encryption or fake SSL certificates, the web server, the standard, the OWASP top 10, cross-site scripting, cross-site request forgery, input validation. And then again, databases with like SQL injection, which is part of the OWASP top 10, and things of that nature. So you may be wondering, okay, why Android? Well, Android devices are severely fragmented, meaning that a Galaxy phone will not have the same functionality as a Note, right? Also, Android is open, and mobile providers most times add custom code on top of the Android operating system to make their devices unique. So that's what I mentioned before, like the Galaxy X6 might not have the same code as the Galaxy Note. So this leads to interoperability issues, meaning I could have two devices that have the Android operating system, but if there are custom code on top of one of them, it will not be the same. And it will lead to different results and different outcomes. So that's the thing between Android and, well, some of the things were Android and Apple. With the iOS, for the most part, it's very streamlined. It's like it's, one, user, it's pretty tightly coupled, it's pretty tight. Also, it's not open source. Apple is proprietary. You don't have the source code. It's not open source. It's owned by Apple. So in that regard, iOS is very, tightly coupled. I'm just to the quick caveat, I have not done iOS. If you have, I would love to talk with you. All of my stuff has been in Android. So where do you get Android apps? So as I mentioned before, the Google Play Store, which is the official repository for Android apps, but there are other sites like APK Mirror, APK Pure, and Aptoid. I put stars here because you should use these sites at your own risk. Again, the Google Play Store is the official repository. But for instance, if you are, wanting to test an application and for whatever reason, you're not finding it on the Play Store, or you're just like, I just can't find it, or the wrong version, whatever, and you find it from these other sites, again, just use it at your own risk, right? Because again, malicious apps, counterfeit apps could be there. So rooting. So in Android, it allows for a small subset of applications to run with root privileges. So the Android operating system uses the Linux file system, and with Linux, you have a user, which is root, which is like the super user, which can do anything in the system, right? So Android has the same concept where the root user pretty much has the keys to the kingdom. And so when you are root, Android operating system does not stop the application to modify the operating system, the kernel, or other applications. So when you're root, you have full access to applications, data on the device. As I said, you have keys to the kingdom. So also when you allow your applications to run as root, you increase the threat exposure on your device for malicious applications and application flaws. So again, you should very sparingly, almost never have your apps run as root. That should be like a special case. And most times, like if you have an app and you download it from the Google Play Store and it's like, hey, we want to run as administrator or super user or or root, you should definitely deny. You should not give them access, because if you do, then essentially that app can do anything on your smartphone. It can, delete data, it can add data, it can do anything. So in that case, you want to be very, very careful. So we're going to talk about components of an Android app. So there are 4 components: an activity, a service, a content provider, and broadcast receivers. So let's get started. So an activity, it represents a single screen with a user interface. So this is similar to a window in a desktop application. And so an Android app can have one or more activities. Now, in an Android app, where we will see later, every app has a main activity. And that main activity is the entry point to the application. So if you have an Android app and you do not see a main activity, it will not work. So that's, one of the rules for Android is you need to have a main activity. Next, services, and I've broken them down into 3 different services. So the first is the foreground service. So this is where users can interact with the service by notifications of an ongoing task. So an example of this is when you're downloading a file on your smartphone. You download a file, you can see, the percentage done, you can stop it, you can pause it. This is a task you can actually interact with. This is a service you can interact with. A background service is, no user interaction. So again, the services do not notify the user of ongoing tasks, or you can't interact with it. So an example of this is like syncing data, right? If you have like a Gmail or an email app on your phone and it's syncing between your smartphone and the server, you might see a dialog box that says syncing data, but you can't stop it, you can't pause it. you just, that's a background service because you really can't interact with it. You see it, but you can't do anything with it. And then finally, bound services. And these are services that perform their tasks as long as the application is bound to it. So for instance, if I have an application and it's bound to the operating system for 10 minutes, then that is a bound service that is bounded for 10 minutes. And then once it's done, it's unbounded. It's not bound anymore. Content providers. This supplies data from one application to others on request. And you can think of a content provider as a centralized place of content, and it allows different applications to access it. So if you look to the right of this slide, you will see different apps, 3 apps. You will see the content provider is in the middle, and then you will see like different, like the internet, a database, SQL, files, and you will see that you can read and write, and the content provider is like the middleman between the apps and the data layer. So it's like the middle layer of saying, hey, okay, all of you apps come to me, then I will interact with the things you want to do, and then it will go back and forth that way. Finally, broadcast receivers. These receivers respond to system-wide broadcast announcements. And so, for instance, these are messages are called events or intents. So, and some examples of this is, when the screen has turned off, we turn off the screen, or when it goes to sleep, and low battery. So, as you can see, the broadcast receiver registers intents to be observed to the Android operating system, and then the Android operating system gets notifications when the intents occur. So it's more so of a circle pattern. So Android x86. So this is an emulator. I have this on my SourceForge site that I put in the Discord, the Red Team Discord. So I should say, when you're doing Android hacking, you should probably have an actual physical device. But for this workshop and, for you to get started, I have included an emulator for you to start testing things out, until you get an actual device. So this emulator can be used to test applications. The current release is based on Oreo. Some common features are Bluetooth, Wi-Fi support with GUI, debug mode with BusyBox. You can also log into a Gmail account. This is important. Again, if you want to download apps from the Google Play Store, you would need to have an official Gmail account to do that. But if you do that on this emulator, I would suggest to create a test account and use this test account to download applications. I will not use my real email. I'll just use that as a quick caveat. So, intro to Android Security Virtual Machine. So this is a virtual machine that I created that has the common Android hacking tools that you need. It is based and built upon Ubuntu 18.04, Bionic Beaver. It was also inspired by Android Tamer, which is another Android hacking tool that has common Android tools in a virtual machine. So I was heavily inspired by that. So show them some love on Twitter. And some tools that are in the virtual machine are manual dynamic analysis, penetration testing, reporting, and reverse engineering. So now let's start talking about some of the tools. So APK tool, what is it? Well, it's a reverse engineering third-party tool that you can use to reverse engineer apps, and you can decode resources to close to their original form. And you can also rebuild applications after modification. And once you actually decompile an Android app or Android package, that's what APK stand for, you would get four different items: Smiley, Res, MetaInf, and Android manifest.xml. And I will talk about all of these in a second. So if you look to the right of this slide, you will see like APK tool D. The D is for decompile, and then you specify the actual Android app. Android apps and in .apk or Android package. And you will see that it's actually decompiling this app. So Smiley, what is it? So it's an assembly language used by the Android Dalvik virtual machine. So assembly language for most people, so assembly language is used in computers. So like in your interpreted language, or excuse me, your high level languages like Java, .NET, all of these things can be broken down into assembly language, which is like the low level, bare bones of programming languages. You could program in assembly. I wouldn't recommend it. I haven't done it in over 15 years. I did it when I was in undergrad, for a course. Most times you really don't program in assembly. And if you do, hey, all power to you. So Smiley is similar to that for Android because it is like the bare bones of an Android app. And it is the workhorse of Android apps. It's decompiled to a .dex, which is Dalvik executable. And again, it's used for low-level inspection of Android app content. So you can look to the right of this slide and you can see kind of like the bare bones. We see like .line 104. We see, line 354 if equal to 0, and you're checking like a V13 and it goes to like condition 0. As you can see, it is very low level, like it's low level. I should also specify that Android apps are written in Java. So again, this is when you look at an Android app, you will see it in Java, but the Smiley is like the bare bones of that Java. And this is an example of that. So Res, this is a folder for additional files and static content. Things you would have are images, layout definitions, user interface strings, and animation strings. And these are all in relation to the Android app. So everything that's more so visual for the Android app, you will see that in this folder, the Res folder. And if you look to the right of this slide, you will see an Android app, and you will see like the main activity, which I mentioned, every Android app has a main activity, and you will see that it's also written in Java. So that, to the right, this is Java code. So MetaInf, this folder has three contents in it. So cert RSA is the first, and it contains the signed contents of the cert SF. So this is signed with the developer's public key, the private key, and the public key is used to verify the signature. So cryptography is a little bit outside of this course, but there are two facets of cryptography. You either have symmetric cryptography, where you have one key between the sender and the receiver, or you have asymmetric cryptography, and where you have pairs, where each pair has a public and private. And as the private specifies, only you should know that, you never private. So in this case, what happens is the developer signs with their private key, and then the receiver will then verify with the public key. And if the developer will sign with their private key, and then the receiver would then use the developer's public key to get the original contents. So that's how that works. And why you want to sign with the private key with code signing, it's additional layer to verify your contents, also make sure it's not being modified or compromised. Cert SF is a list of all the files with their SHA-1 hash. And with the hash, it's a one-way function, meaning you can complete a hash, but you can't go back to its original form. And again, that is used for entry purposes to make sure that your files have not been manipulated. And then the manifest.mf, which contains information of the application, such as package version, build number, creator of the package, etc. So to the right, we have, a folder that shows the 3 different files that I just described in the meta-inf folder. Next is the Android manifest, and this is located at the root of the project. Just like with a main activity, every Android app has an Android manifest. And you can think of the Android manifest as a skeleton of the app. It pretty much describes everything about the app. So the manifest declares the app's components, such as the components of the application we talked about: activities, services, broadcast receivers, and content providers. It also talks about permissions the application can use for APIs or application programming interfaces. It describes the permissions that the app has. It also declares the minimum level of Android that the application requires. So in this case, if you look to the right, we see here that a manifest, and it's pretty much a basic standard manifest. As you can see on line 6, we have the application line. It talks about the activity, and inside of the activity in line 9, we have an intent filter inside of it. And then in line 16, we have a uses SDK, min SDK version of 2. So this application can use any level of the Android operating system. It's pretty much the first Android operating system. So again, with the min SDK version, it will be a number. So you won't see like Android 9.0. You will see the actual numeric equivalent of that. So like SDK version 42, I'm making that up. And then you could correspond that with the operating system that it will use. So as I mentioned before, permissions. So normal permissions, these permissions do not pose a to users' privacy or device operation. And the system automatically grants these permissions to your app because, the Android operating system sees these permissions and it's like, oh, yes, this is fine. These apps will not hurt me. Oh, yes, I approve you. No problems. So some examples of normal permissions are like Bluetooth, change network state, disable keyboard, get package size, internet. It's like, okay, we have decided these are normal permissions that are not here to hurt. So yes, I approve. Next are dangerous permissions. And remember, in the second case study, I mentioned about that, with the counterfeit apps, it found that there were at least 5 dangerous permissions. So these permissions could potentially affect the user's privacy or the normal operation of your device. So when an app is using a dangerous permission, your phone or you will be notified to say, hey, do you want to use do you want to use this? And I'm going to show an example in a little bit. But some dangerous permissions are read calendar, write calendar, read contacts, write contacts, record audio, read phone state, call phone. These are all the things that could change the normal operation of your device or privacy. So unlike normal permissions where the operating system is like, okay, yeah, I approve you, this is fine. With dangerous permissions, the phone is like, whoa, I see these permissions here. This can change my state. I'm going to present a dialog box, and it's like, hey, do you approve this? And if you say yes, it's like, okay, well, that's fine. You know, I'll grant you access and you can keep going, but I'm going to alert you. So for this, for Android devices running Android 5.1.1 or lower, the system will ask this at installation. So when you install an app and you're like, hey, install, and then a pop-up will come up and it's like, this app wants to view your contacts and look at location and microphone. Do you accept? Almost like this, the screenshot on the right of the slide. It's like, hey, do you accept? And if you say, you press the accept button, then it's like, okay, well, you're aware of the challenges or the things that could go wrong and you accept it, so I'm going to keep going. Now, for Android devices that are running 6.0 or higher, it will not prompt you at install time, but rather at runtime. So what happens is for later versions of Android, you press the install, it installs perfectly, no problems. But when you click to actually run the application, and that's what runtime means, when you click to say run, then a dialogue will come up and it's like, hey, you know, this app wants to look at your, you know, your pictures and record audio. Are you sure about this? And again, like the screen right, it gives you an allow or a deny. And if you say deny, depending on how the application is set up and the permission, if you click deny, the application might not run. It might just quit altogether. It might be like, oh, this permission is needed to execute this application, you know, quitting, right? Most times, if you say deny, it, you know, the app for the most part will still run, but that functionality will be turned off. And again, you know, I'm just going to keep specifying this. Be very cognizant and very active on the permissions that your applications need. So as I said before, if you have an application and it's an application that changes colors, and it's like, yeah, I need to access your contacts, you know, I need to access your phone. You know, that should be raising a red flag because it's like, okay, this app is just changing colors. Why do you need my phone to change colors? Like, you don't need that, right? So again, you have to be very cognizant of what the app is trying to do. And I know for most people, they just get an app and they're just like, install, allow, without really looking at what's going on, what they're actually allowing onto their phone. So the next set that I'm going to explain is, you know, what we all want to do, which is reverse engineer an app. So in this case, what we have is JADX GUI. There's also JADLI, which is the command line. And again, it depends on your flavor. And it's a DEX or Dalvik executable to Java decompiler. As I said, Android apps are written in Java. And in this case, the GUI is a tool to produce Java source code from Android DEX and APK files. So APK or Android package files, which are Android applications. So to the right here, we see, you know, we have actually decompiled an application and we're looking at the source code. We're actually looking at the source code of an application. So you're like, ooh, okay, I'll use the JADX GUI and I'm in there like swimwear. Well, not so fast. For most applications, they're going to make it hard for you. So for instance, if I'm a developer and I'm like, developer, I don't want you to look at the logic of my application, right? So I'm going to use a concept called obfuscation. And so that is the process of trying to make in this case, code, obscure, unclear, or unintelligible. And so most of you, or some of you, have heard the concept of security through obscurity, right? So this is what it's doing. So it's like, hey, you know, I have my nice code and I'm going to put it in jumble words that are like unclear and unintelligible, because in my mind, that is going to, you know, thwart you, and you're not going to want to figure out the logic of my code. There are tools to de-obfuscate to the original code, and one such tool is ProGuard. Also, if you don't have ProGuard, what most people do is they'll look, you know, they'll just look at the code and kind of like piece it together. And that's what we're going to do in our case. So yeah, so it's like, even with reverse engineering, most times you'll look at the source code and it's like, wow, this is like gibberish. And that is done intentionally, because it's like, I don't want you to know the functionality of my code, because at that point, you know, you can change it, right? For instance, if I have an app and, you know, let's just say Facebook, and it's, you know, you decompile the app and you look and it's like, hey, you know, the server, this should never be in there, but, you know, the server for the, you know, username and password, the login credentials, you know, it's this specific server. Well, if I know that, I can change it from Facebook servers to my own servers. And then I can rebuild the application and push it back to the Google Play Store. And then when people download that app, they put in their username and password, they put in their credentials, thinking they're getting into Facebook, but they're really sending it to your server. So then you have effectively captured username passwords that you can then use for nefarious purposes, right? So a way that developers try to mitigate against this is to use obfuscation, because in their mind, they're thinking, okay, if I make it unintelligible and, you know, like gibberish, you know, no one is really going to spend time actually try to piece it together. But that's not the case. So next, Android Debug Bridge, ADB. So this is a client server program, and it's used to connect. We're going to use it for our emulator, but if you actually have an Android device, you can use a USB from like the phone to your computer and use it that way. And it's a client server program that has the following components: a client, which sends commands to the device, daemon that runs commands to on the device, and this is in the background, a server that manages communication from client and daemon, and this also runs in the background. So on the right here, we see ADB Connect, and what this is saying is, hey, you know, we have a device and we're saying, hey, connect to this device, and we provide the IP address. And then the next command, ADB devices, it shows that, okay, it has connected successfully. And for ADB, the port is 5555. So common ADB commands: ADB connect, which we just shown, ADB devices, -L, that's a lowercase L, queries the list of attached devices. ADB start server, it starts the ADB service. ADB kill server, and again, this kills the ADB service. ADB install, this installs an application to the device. ADB logcat, we use this to dump system log. ADB push, this is used to copy files, directory and subdirectories to the device. And ADB pull is sending from the device to your computer. So Frida is a dynamic code instrumentation toolkit, and you can modify logic in mobile devices while it's running. So Frida is considered dynamic analysis. So for instance, you might have an application and you click on it and it's like, hey, you're root, you know, I'm closing, you can't do anything because you're trying to run as a super user and I'm not going to allow you to do that. So what you can do is you can use Frida, hook into Frida. And again, this is where the reverse engineering comes in, find the logic of where, it's doing the for root or super user, and then you can write code. And again, Frida uses JavaScript, Python, C, Swift, and .NET, as well as other languages. And you can write a nice little script and inject that into Frida and then re-execute the program to mitigate and bypass those checks. So Frida is a dynamic code analysis tool. Again, Frida is so powerful that I have sites at the end for us to for you to look for after this course, after this workshop, to continue on with your learning. One of those is Frida, because there's so much you can do with that, like to bypass things and, do all the things. I will not be doing it justice in this workshop. Next is MobiSF. And this is the mobile security framework. And so this is an open source intelligent tool that can be used to perform static and dynamic analysis on both Android and iOS platforms. So it also has web API functionality to do information gathering, analyze security headers, also look for vulnerabilities such as XXE, XML entity, or SSRF, server-side request forgery. So if you look to the right, here is a screenshot of MobiSF. And as you can see here, it lists the 4 different components that I talked about: the activities, the services, the receivers, and the providers. And it gives us a good information about an Android application. So for instance, if you're under the gun and you're like, hey, I just want a quick snapshot of what this application can do, you can put it into MobiSF, and then it will give you, the basics, and then you can go from there. So in summary, attack vectors are wider in mobile apps. The barrier to entry is pretty low in Android because it's open source, and you can reverse engineer these apps. And, you can do that to look under the hood. As I mentioned before, Frida is a good tool to use for dynamic analysis because you can change logic on the fly and bypass checks that, developers have put in, like, haha, I got you. And it's like, no, bypass that. And then also, there's no silver bullet with mobile security. So what might work in one instance, like one Android device, will not work in the other because, again, due to interoperability issues, there might be custom code in one that's not in the other. So again, every Android device is, you should really treat it as a case-by-case basis. So for continued learning, inside of my Intro to Android Security virtual machine, I have included some apps for you to play with. MSTG Hacking Grant is the mobile security testing guide from OWASP, Open Web Application Security Project. That is their app to play with. Also Diva, IG Learner, and the Uncrackable series, and there's levels 1, 2, 3, and 4. Level 4 has 2 apps, and it's the R2Pay, and both of those apps are for level 4. And so what you can do is you can push these apps to the Android emulator using the Android Debug Bridge or ADB install command. And then here of the additional learning, I've included HackerOne. They have a playlist. F, it means free, so you don't have to pay. There's also some more challenges. So MobiSec is also free. And then Pen Tester Lab has Android challenges, but you have to pay for those. Suggested reading, just more on the Android fundamentals, JavaScript, Java, or Python. Again, you don't need to be, a guru at this, but if you know how to read especially with Java or Python, because you can use that with Frida. If you can read and then do basic things in it, you'll be great. Java, again, because Android apps are written in Java. So if you know Java to the point that you can read and kind of deduce what's going on, that will be good. The Android debug bridge to learn more about that, and Frida, which is the dynamic analysis tool. So now what we're going to do is I am going to go to our application portion. So I'm going to open the Android Intro to Android Security. The current version is 2.0.1. I'm going to open that, and I'm also going to open our emulator.
Hey, Jasmine, just one quick question. Sorry to
Yeah.
interrupt you. So we had a question in Twitch, and I think in a couple of places on where the Android x86 link, the external link to a Google Drive is not working. I think that you have to change the permissions so they can follow along.
Oh, okay, darn.
Yeah.
I thought it was working. Okay.
Probably do it after the.
Yeah,
after
I'll
the
do
spin.
it after. I'm so sorry. I thought it was working. Darn.
No
Okay.
worries. No worries.
Okay, sorry, y'all. That, yeah, my bad. Okay, so I want to see if I can put these side by side. Hopefully the demo guys are with me today. Okay, so for the Android intro to Android security, the username is Android. The password is security, lowercase. And I should also mention that for the emulator, it takes a lot of memory. So right now I have 4 gigs for just this emulator because it takes a lot. So just be mindful of that. So if you use like a few gigs, it will go very slow. And again, as you can see, I have 4 and it's still not as fast as I would like. It's okay. So I just want to make that be known that the emulator uses a lot of memory. So while we're waiting for the Android emulator to load, what I can do, so my intro to Android security VM is to the left here, and I'm trying to have them side by side, so excuse me for that. So I opened the Android home folder, and if we go to documents, here is the apps that I had listed. Now, disable root and disable root 2, you will not have those files. That was something that I did when I saw the first level of the Uncrackable challenge on my YouTube. So you would not have these 2 files, but everything else you would have. Okay, for the Android emulator, there will be times where it's like the system UI isn't responding. So what you can do is click on wait, and then it will come up. Okay, and as you can see, the tablet is starting, so the emulator is starting. Okay, wait again. Sometimes it can take a while. Okay. So what I'm going to do here is, now what we're going to need to do first from our emulator is we need to go to to go to the terminal emulator. loading, I promise. As I said, this takes a lot of memory. So I'm trying to wait for this to load. Because I feel like, okay, it's about to load. So I feel like if I go and talk about the what I want to talk about in the intro to Android for security is going to load. So it's loaded now. So what we're going to type is ifconfig. And what we want is the WLAN 0. We want this IP address. In this case, for mine, it's 192.168.1.92. Because what we're going to do here is we are going to click on menu and type terminal and click that. And what we're going to say is ADB connect. And we're going to use that IP address, 192.168.1.92. So now we have successfully connected to our emulator. So now these two virtual machines are talking to each other. So I have already installed the app that we're going to use, but I'm gonna do it again. So to show you guys, so what I'm going to do is I'm going to go to the download documents directory, and I'm going to do a ls-la. So what that says is a long listing showing everything, including hidden files, and hidden files are designated with the period before. So what I'm going to do is I'm going to bring the iglearner.apk. So what I'm going to say is adb install iglearner.apk. And I'm going to press enter. Okay. And we should get a success to show that it installed properly onto our device. Yes, we did. So if we go back to our emulator here and we click the 6 dots, we see here IG Learner. It has successfully installed. So we have successfully installed onto our emulator. And again, it will be the same thing if you actually had a device, except you would have a USB cable from the device to your computer. And it will be the same thing, ADB install. So now what we're going to do the first lesson, and I'm going to try to make this bigger. Okay, thank you. And if I click on lesson 1, let's see instructions. Okay, I'm trying to make this bigger. Bear with me, you guys. Okay, the secret code is lurking somewhere in there. Find it, and when ready, enter the code in the provided box and press the submit button to see if you're correct. So we need to find a secret code. Okay, so now we're going to reverse engineer an app. So going back to our intro to Android security, virtual machine, we're going to click on menu. We're going to go to reverse engineering, and we're going to click on JADX GUI because I like working with the GUI as opposed to the command line. But again, it's your flavor, what you want to do. You click on that and it should open. Yes, it opens and it's like, okay, what do you want to open? So we want to open the IG Learner APK. Okay, so now if we click on, we have inside of the comment reputusgroup.learner. So this is a package, and this is a Java term. This is a package, and then these are files under that package. So again, we want to go to lesson 1 activity. So I want to make this bigger here. So we are now looking at the source code for this activity here. As I said before, Android apps are written in Java. And if we scroll down, we see on create, we see things that are being done. Now, we also see this challenge, generate challenge. We see a field log with garbage. We also see lesson 1 on submit. So scrolling down, this is where the reverse engineering comes in, because now we have the code. We need to see what the app, in this case, what this lesson actually does. So we see a generate challenge, and we see we're doing like some randomness with the alphabets. And, we're doing, some randomization. But if you scroll down to field log with garbage, we see here that we have this log of learner here. And if we scroll, we see learner, and we see string value of, and then we have, generate challenge, and then this dot challenge. So it seems like we're going to have to look at the logs to get our string. So what we can do, so if I scroll here, okay, so we know we have this learner. So remember, inside of ADB, we have an ADB log, and I believe it's log cat. So what we can do is we can go back here, and we can say ADB log cat learner. Okay, and then I want to grep for learner. So now it's just waiting. So let's see if I type test and press submit. Okay, that was not the correct answer. Okay, I think I'm using ADB in the, oh, okay. So I did, okay, so did I close this to, okay. Hold on, let me. Okay, I wanna maximize this. Okay, so we see here, okay, it's giving us learner, but it's not giving us what we want. So let's go back here, and it's like, okay, let me, okay, that's why I said I hope the demo guys is with me. So let's see if I say ADB log cat grep. Okay, let me try to type test again. Okay, that's not correct. Okay. Enter if I stop that. Because here, what should happen is I should get the correct, oh, sorry. There was something that I missed. So here, inside of the lesson 1 on submit, we see check log string. And so if we go here, it's like, hey, does the string to test equals this challenge. So if we look inside of field log with garbage, we see here that the first is this dot challenge. So it's saying, hey, you know, this is what we want to execute because that will point us to the correct value. But let me go back to my slides very quickly because it's like, I don't think I'm using the ADB log. Okay, ADB log cat. I don't know if that's what I was typing. No, that is what I was typing. Okay. So ADB. Okay, so it is logging. So say okay, that's what I'm typing. So say ADB. Not correct. Okay, so what I'm going to do now, because I don't know what is going on, and I kind of figured that was going to happen. So what I'm going to do now, I will provide updates on that. I will go to lesson 3. I don't know what's going on with my log, why it's not coming up. So let me try lesson 3, if this will come up. Okay, so what I'm going to do now is I'm going to go to lesson 3 activity. And so here we kind of have some of the same things. And if we scroll, we see here, we have a lesson 3 on submit, click, and it's saying try file Android assets test.html. And it's saying, hey, okay, we're going to try this. And if it doesn't work, we're going to output an error with a log. So let me wait. So here, if we have IG Learner, and if I click request URI, it shouldn't work. I should be getting an error. What is going? Okay. This. Okay, because it should be giving me like incorrect. Like this should be red and it should be incorrect, and it's not doing that. Okay, I kind of figured this was going to happen during the demo. Because essentially what we want to do is okay, so click me. This is what I was waiting for. Click me to see what happens. So locked, right? So we need to unlock it. And so if we go back, and if we, okay, I went back too far. And if we said, And if we tried, let's see. Okay, so this is what I was looking for. So in the lesson 3 handler activity, you see the unlock key is crazy URI handler. So here it's saying, hey, if the path contains crazy URI handler, then we're going to use that to unlock. So let's change this to, instead of test me, to crazy URI handler and say request URI. Okay. See, we solved the challenge. Okay. Oh, okay. One, I need to go back and see what's going on with lesson 1. So let me explain what happened. So we had lesson 3 activity. And again, Android app, it has an activity. So this will be the main activity. So I looked here and I didn't see what I was looking for. So I saw, you know, some things like on back press, finished, you know, lesson 3 on submit, click. And, you know, it tried loading this URI. And then if there was an error, it would do a log. But then I was like looking to the left, I see that there was another activity for lesson 3. So clicking on that, we see an unlock key. And remember, when we first pressed the, you know, click me to see what happens, we got a red locked. It was like, hey, locked, you can't go any further. So now looking at this lesson 3 handler activity, we see, hey, this is the string we need to actually unlock this challenge. Crazy URI handler. And when we put that inside of our URI and then pressed request URI, I'm gonna do it again. And we said, click this request URI. And then it's like, hey, click me, see what happens. And we have successfully completed the challenge because we have unlocked it. So this is an example of reverse engineering an application, because again, we're looking at the source code for this lesson, lesson 3. We're looking at it, for the most part, this really isn't too obfuscated. You can kind of follow along. There are other, like I know for the uncrackable challenges, if you do that, that is obfuscated and you kind of have to do piece by piece. And so again, this isn't too obfuscated, so you can look and it's like, okay, it's doing, you know, it's looking for submit, it's doing backs, and it's like, okay, but I really don't see what I'm looking for in this file. So going to the second, it's like, it's locking me, so I need to unlock it. And it's like, oh, hey, you have the unlock key hard-coded inside of your application. So if this was a real application, like on the Play Store, you wouldn't to do this here. This is a no-no with actually hard coding. You know, again, this app, the IG Learner app, as it, you know, as the name, you know, specifies, is for you to learn, right? So again, you will be surprised when you look at real apps where they'll hard code things, because again, they'll think, you know, no one's is really going to reverse engineer this and look at my code. No, don't do that. So this is a big no-no, but in our case, this works because this is a workshop. So we have the unlock key. And then if we scroll down, we'll look down, we have an on create, and it's like, hey, we have, let's get the intent. We have the URI string, and we get the path, right? And then it says, hey, if the path, this is a conditional. So it's like, hey, the path that we just constructed in line 29, if it contains crazy URI handler, our unlock key, if it contains that, hey, just unlock it, just unlock the challenge. We've solved it. So that's what that says here. The lock status set text is to the unlock string. And that's what we did there. So this is a quick example of reverse engineering an app, looking at the code to figure out what it does. Now, remember I mentioned resources, right? And I mentioned like the res, the Android manifest, and all of the things. So if we click on Android manifest, this one is pretty big because it has all of the lessons here. So you see that, for permissions here, it says read phone state, we have internet. You see that the mid SDK version is 14, the target is 16. So again, we're seeing, okay, for this application, these are the minimum SDK version is 14. We see here, we have, lesson 2, it points to the activity. And it's like, okay, hey, these are the activities that we need. So again, as I mentioned before, the manifest is the skeleton of an Android app, and it specifies pretty much, how your app is going to flow. And then we have the meta inf, and here for the manifest.mf, as I said, here are the SHA-1 hashes. And again, this is used for integrity purposes to make sure it hasn't been altered. But now, let's see if this will work. So remember, I mentioned MobiSF, right? So if I go here, also let me describe how this works. So for the MobiSF, first, what you would need to do is start the server. And the password is security, lowercase. So it's in a Docker container. So we're going to start Docker, and it's like now starting MobiSF. And again, like if you're like, hey, I need to look at this Android app and I really don't have a lot of time, you can use this. It's a good app that has like dynamic and static analysis. And it's loading. And I'm trying to wait till it's done so I can bring it up. Okay, so now it has started, because once you see booting worker with PID, with process ID, now you know it's working. Let's see if I start the UI. This will work. Okay, so inside of the intro to Android security VM, I try to make it as painless as possible for you. So it's like you start the server and then you can start the UI. So it's like, it's pretty much just click. Okay, so next what we can do is we can pick, let's just say I'm going to pick, okay, I didn't want to make that big. I'm going to pick the crackable. level 1. And I'm going to down, you can drop it anywhere. So now it's analyzing. I just want to show you how MobF works, you know, how it works when you use it. So it's analyzing. Please give it a little bit of time. While it's analyzing, I should say, since we are in a virtual machine and it is using Docker, the dynamic analysis portion of MobSF does not work. It doesn't work in a virtual machine and it doesn't work in a Docker container. So let me specify that quick caveat. So it's like, hey, I want to do dynamic analysis. You won't be able to do it inside of the virtual machine. You would need to set up MobSF on your actual physical machine if you want to do dynamic analysis. You can't do it in a virtual machine or a Docker container. So I want to specify that. So as you can see, it pretty much has gleaned a lot of the data for us. So for instance, the average CVSS score, 7.5, secure 90 out of 100. You know, it gave us the name, the package, the main activity. Remember, every Android app has a main activity. It gave us the target and minimum SDKs for it to work. You know, if we scroll down, we see we have 1 activity, 0 services, 0 receivers, 0 providers. And again, so the dynamic analysis, excuse me, because I am in a virtual machine and it's also in Docker. So if you use this inside, if you use this virtual machine, the dynamic analysis portion will not work. And I'm just keep mentioning that because it's like, I don't want people to try and it's like, hey, it's not working. That's why. So we can look at the manifest, we can look at the source code, the Smiley, and here it's giving us information. And then if we scroll down, it's like a warning, you know, this is application is signed with version 1 signature scheme. And it's making it vulnerable to the Janus vulnerability on Android less than 7.0. And then we can see, you know, it gives us a lot of information and it's like, hey, you know, application data can be backed up. So again, I'm just showing this. I'm showing this. So if you're like, hey, I have an app, I don't have a lot of time, but I need to get like a baseline, you know, of some things that it can do, and then I can do research from there. MobSF is a good tool to just dump it into to kind of see what it returns. And then, you know, you can go from there. So again, the app may request root or super user privileges. And then it gives, you know, the rating. App logs information, sensitive information should never be logged. So again, MobSF is a really cool tool to use. And again, you have, you know, all of these things on the side, like malware analysis, reconnaissance, and things of that nature. So one final thing, because we got less than 10 minutes, I mentioned the APK tool, right? So let me open another terminal or another tab. And I'm going to go to documents. And what I'm going to do is I'm going to say APK tool D, and I'm going to do the uncrackable level 1. So what I'm saying is, hey, decompile this uncrackable level 1 Android app. I'm going to press enter. And as you can see, it's actually decompiling. So for instance, if we didn't have the JADX GUI on this virtual machine, you can actually use the APK tool to decompile. And then if we go back to the documents folder, we now have the APK, the uncrackable level 1. And now we could actually, where is it? Okay, that's the Smiley. but we can actually look at the code this way. So again, it's more so picking your poison. I like the JADX here because it's a nice way to look at everything. And then, I don't need to decompile anything. All I need to do is just open, JADX GUI, point it to the Android app. It does all of the decompiling for me and actually shows the Java code. So it's kind of like a one-stop shop. So I would say before using mob SF, it would be good, if you looked at JADX GUI on your own, actually look at it yourself, even if you spend like 10 to 15 minutes, just look at everything, look under the hood yourself before looking at a tool. I mean, just my personal preference is I would like, knowing what's going on under the hood using tool, right? Because, the tool is great, but, it's just great to kind of like second guess because there might be things the tool doesn't find that you find, with looking at it with your own two eyes. So we have 8 minutes left. I guess this will be a good stopping point for me for this workshop. And again, sorry about lesson 1. I don't know what happened with the demo gods with that, but I did show it with lesson 3, reverse engineering. It was locked, finding the unlocked key, even though you would not want to have that in an app because that would be considered like a hard-coded password of sorts because essentially it unlocks this this activity. So you really wouldn't want to do that. I guess if there are any questions, Omar, I could take them. I know that I need to change the permissions for the Android x86 after this workshop. Sorry about that. I thought it was correct beforehand. So again, sorry, I would definitely change that. But I guess we got 7 minutes left. So if there are any questions.
One question that came in through Twitch that I saw, and it was a little earlier, will apps written in Kotlin decompile to Java?
That is a good question. Let me get back to you on that because I don't want to give an answer and it's not correct. A part of me wants to say yes, but I also know that some apps, it's Java, but then some libraries might be in C and C++. So let me get back to you on that because I don't want to give you the wrong answer.
Okay, no problem. Yeah, I think the answer is probably not, but I'll let you.
Yeah.
And let's see if you have any questions. So there's a couple of seconds of delay between where we open for Q&A and you're able to answer or you're able to see the questions or vice versa. Let me check on Discord.
Are the questions inside the Discord? Because I
don't see any questions in the Discord server or Red Team Village. Let me check because we have so many.
I know. Yeah, I just want to. If there are some questions, I just.
The only other one was earlier today. Will your slides be available?
Yes, my slides will be available. I will have it on my site, the Fluffy 007, and I'll post it on. I will send a tweet when it's available.
Okay, perfect. And then I'll put in the Discord server.
Yeah.
Awesome. Yeah, I think those are. Okay, there's one more. So I have a question. Like when an API disclosure has information leaks, how the impact will be? Let me see if I can paraphrase that in the Java code. I mean.
Mm-hmm. Okay, the impact. That's why I kind of wanted to show the first exercise that didn't work. I mean, it depends on what's being leaked, right? So, for instance, if you were leaking, let's say, bank account information or social security numbers, the impact of that would be very high, right? Because that's personal identifiable information. So then, it depends on what is being leaked. I hope that answers the question, unless there's something else.
I think that was the question. And
Okay.
and if not, they will probably type it in a few seconds.
Yeah.
About 40-second delay between whenever we talk and they can
That's
see it.
fine.
But yeah, I'm monitoring here.
Okay. Yeah, I just want to be respectful because I know we got like 4 minutes left before the ending. So I
No
kind of
worries.
wanted to take a few questions, but also wanted to be respectful for people who wanted to go to the closing ceremonies.
Oh, that no worries. We're not overlapping with that. So
Okay, cool. Okay.
we have all the time. Now there's another question coming in. How accurate are the analysis with tools like MobSF or Cuckoo Sandbox?
Okay, so MobSF recently went through a major upgrade. They're also on GitHub. So for the most part, I know this tool updates pretty regularly. So I know they did a major upgrade like this year, like earlier this year. And again, they have Twitter. I know they have a Twitter account and they usually announce they will do upgrades. Most of the tools that I have inside of the virtual machine have GitHubs, and then for the most part, most of them are updated regularly. Some of them not. It might be infrequent, but for the most part, a lot of them are updated pretty regularly.
Yeah, it actually looks like MobSF was updated a couple of weeks ago.
Yeah. Yeah, so they're really, really good. Actually, the gentleman, Anant, who is the creator of Android Tamer, that was the inspiration for my virtual machine. He actually is a part of MobSF. So he like does testing, and I think he provides functionality and things of that nature. So yeah, they update regularly, pretty regularly.
And then one last question from Zaid NZ. It says, you mentioned that MobSF dynamic only works on actual devices, not on VMs. Can you clarify on that?
Yes. So if you look on their GitHub, it doesn't work inside of virtual machines and or Docker containers. So I'm using a virtual machine. This is a virtual machine here. It will not work. Also, inside of the virtual machine, the MobSF application is inside of a Docker container. So on their GitHub, they explicitly wrote if you're using our program inside of a virtual machine or a Docker container, the dynamic analysis doesn't work. Like the functionality doesn't work. So you will actually have to download the MobSF application on your physical computer if you want to use the dynamic analysis. So that was something that they called out on their GitHub.
Perfect. And I think that's it. Those are all the questions that I see. Thank you so much. I really appreciate your time. Thank you for supporting the Red Team Village.
Yes, thank you. And again, sorry for the lesson one. The demo guys were somewhat with me here. They weren't with me all the way. But again, I hope everyone has learned a lot. I will provide the slides. I will do the updates for the Android x86. I also have a walkthrough to get everything set up. So again, I hope you guys continue on your learning with mobile security and have a good day or night wherever you are. Thank you again.
Thank you, everybody.
Okay, bye.
All right, we are